Hello and welcome. I'm truly delighted you're here. Before we get underway, I'd love for you to share in the comments where you're tuning in from and what time it happens to be in your part of the world. It's always such a joy to see this community come together across places and time zones. I also want to take a gentle moment to thank everyone who's subscribed and shown support through likes on the videos. It helps me know what you value most, and it helps others find this space too. Please feel free to leave your ideas for future topics in the comments. Now, let's begin. Chapter 1: Understanding Oceanic Vortexes. Oceanic vortexes, swirling masses of water, form intricate patterns that dance across the surface of the sea. These natural phenomena are not just beautiful to behold, they play a crucial role in the dynamics of the ocean. An oceanic vortex can be defined as a rotating body of water, often characterized by a spiral motion. These vortexes can vary in size and strength, influencing everything from local weather patterns to global climate systems. Imagine standing on the shore, gazing out at the vast expanse of water. In your mind's eye, picture the currents swirling beneath the surface, invisible to the naked eye, yet powerful enough to shape the environment around them. Oceanic vortexes are not merely spectacles of nature. They are the lifeblood of marine ecosystems, affecting nutrient distribution and the movement of marine life. The study of oceanic vortexes has a rich historical context, dating back centuries. Early mariners noted the effects of these swirling waters long before the science behind them was understood. The great explorer and scientist, Benjamin Franklin, famously studied the Gulf Stream in the 18th century. His observations laid the groundwork for future exploration and understanding of ocean currents. "We have all experienced the effects of currents," he once noted, acknowledging the profound impact these forces have on navigation and weather. As we reflect on the history of oceanography, we find that the study of vortexes gained momentum in the 20th century. Scientists began using advanced tools and technology to map and analyze these swirling bodies of water. The advent of satellite imagery transformed our understanding, allowing researchers to observe vortexes from above, revealing their intricate shapes and movements. No longer confined to the realm of speculation, oceanic vortex studies became a cornerstone of modern oceanography. Understanding the basic principles of fluid dynamics is essential for grasping how these vortexes form and behave. At the heart of fluid dynamics lies the idea that fluids, including water, flow in response to forces acting upon them. When water is set in motion, it can create a spiral effect. This can occur due to various factors, such as wind patterns, the rotation of the Earth, and variations in temperature and salinity. Imagine a gentle breeze sweeping across a calm sea. The wind stirs the water, creating ripples that gradually transform into larger waves. As these waves interact with each other, they can begin to rotate, forming a vortex. This spiral motion can be amplified by the Coriolis effect, a phenomenon caused by the rotation of the Earth. Picture the Earth spinning beneath the swirling waters, causing currents to bend and twist, shaping the very fabric of the ocean. The formation of oceanic vortexes is often influenced by temperature gradients within the water. Warm water tends to rise, while colder, denser water sinks. This vertical movement can create layers within the ocean, each with its own temperature and salinity profile. When these layers interact, they can generate instability, leading to the formation of a vortex. Consider the ocean's surface, where sunlight warms the upper layer of water. Beneath this warm surface lies a cooler, darker world. As the warmer water moves, it creates a current that interacts with the cooler, denser water below. This interaction can give rise to a vortex, where the warmer water spirals upward, creating a mesmerizing whirlpool of color and motion. Historical figures such as oceanographer Walter Munk have contributed significantly to our understanding of these intricate systems. Munk emphasized that the ocean is a complex, dynamic system, acknowledging the interconnectedness of its various components. His work on wave dynamics and ocean currents has provided invaluable insights into how vortexes interact with global climate patterns. The significance of oceanic vortexes extends beyond their mesmerizing appearance. These swirling waters play a vital role in regulating the Earth's climate. They help distribute heat around the planet, influencing weather patterns and oceanic circulation. Without these vortexes, the ocean's ability to modulate temperature and support life would be severely compromised. Imagine the vast ocean as a living organism, its vortexes acting as its circulatory system. Just as blood flows through veins, carrying nutrients and oxygen to sustain life, oceanic vortexes transport heat and nutrients throughout the marine environment. This movement is essential for the health of marine ecosystems, fostering biodiversity and supporting the myriad species that call the ocean home. As we explore the depths of oceanic vortexes, we uncover the delicate balance of nature. The interactions of currents, temperature, and salinity create a complex web of life beneath the waves. These vortexes are not isolated phenomena. They are interconnected with global systems, influencing everything from weather patterns to the migration of marine animals. Reflect on the journey of a single drop of water as it enters a vortex. It is carried on a swirling path, encountering different temperatures and salinities, meeting other drops along the way. This journey shapes its experience, and in turn, it contributes to the larger dynamics of the ocean. The study of oceanic vortexes invites us to ponder the mysteries of our blue planet. How do these swirling waters shape the weather we experience on land? What secrets lie beneath the surface of these vortexes, waiting to be discovered? Each question leads us deeper into the heart of oceanography, revealing the intricate relationships that govern life on Earth. As we continue to explore the phenomenon of oceanic vortexes, we awaken to the beauty and complexity of the world around us. The swirling waters remind us of the power of nature and our place within it. The ocean, with its vastness and mystery, calls to us, inviting us to listen and learn from the rhythms of the sea. In this journey of discovery, we find ourselves connected to the ocean in ways we may not fully understand. These vortexes, swirling in their graceful dance, are not merely scientific curiosities. They are the embodiment of the Earth's natural processes, a reminder of the delicate balance that sustains life. The significance of oceanic vortexes extends far beyond their physical presence. They are vital to the health of our planet, influencing climate, weather, and marine ecosystems. As we strive to comprehend the complexities of these swirling waters, we must also consider our role as stewards of the ocean. Imagine standing on the shore once more, the salty breeze caressing your skin. You gaze out at the horizon, knowing that beneath the surface, a world of swirling vortexes exists, shaping the life and climate of our planet. The ocean whispers its secrets to those who listen, inviting us to explore its depths and embrace the wonders of the natural world. As we embark on this exploration of oceanic vortexes, we recognize the importance of understanding their dynamics. The future of our oceans depends on our ability to comprehend and protect these remarkable systems. Each vortex tells a story, a narrative woven into the fabric of the Earth, urging us to appreciate the beauty and complexity of our blue planet. With each gentle wave that crashes upon the shore, we are reminded of the profound connections we share with the ocean and the swirling vortexes that inhabit it. As we witness the dance of these waters, we are inspired to seek knowledge, understanding, and harmony with the natural world that surrounds us. The intricate dynamics of oceanic vortexes are not simply confined to theoretical models. They manifest tangible effects on the world around us. These swirling bodies of water can influence weather events, such as hurricanes and typhoons, which thrive on the energy provided by warm ocean currents. Picture the vast ocean surface, where the sun's rays warm the water, creating a reservoir of heat. This heat fuels storms, drawing energy from the very vortexes we have come to understand. Consider the path of a hurricane, beginning as a humble tropical disturbance. As it traverses warm waters, it gains strength from the energy transferred from the ocean's surface. The vortexes, in turn, play a critical role in shaping the storm's trajectory and intensity. The interaction between the ocean and the atmosphere is a dance of forces, an interplay that is both delicate and powerful. Renowned meteorologist Dr. Carey Emanuel noted, "Hurricanes are heat engines that convert heat from the ocean into wind." This encapsulates the essence of how oceanic vortexes are not merely passive players, but active participants in the Earth's climatic systems. The energy captured within these swirling waters ripples outward, influencing weather patterns across vast distances. Imagine the vastness of the ocean, a theater where the stage is set for these extraordinary events. As vortexes form and dissipate, they leave an indelible mark on the atmosphere. The currents they generate can alter the paths of storms, shifting their movements and intensifying their impacts. The interconnectedness of ocean and atmosphere is a reminder of the delicate balance that governs our planet's climate. Yet, vortexes are not merely harbingers of storms. They also serve as vital conduits for marine life. The nutrients transported by these swirling waters provide the foundation for vibrant ecosystems. As the vortexes rise and fall, they churn up nutrients from the ocean depths, creating fertile grounds that support diverse marine populations. Visualize a vibrant coral reef, teeming with life. The currents generated by nearby vortexes nourish the coral, bringing in plankton and other small creatures that sustain the complex web of life within the reef. Marine biologists have long studied these relationships, recognizing that the health of coral ecosystems is intricately tied to the dynamics of ocean currents. The work of pioneering oceanographers, such as Sylvia Earle, has shed light on these connections. Earle's passion for the ocean and its inhabitants drives home the point that the greatest danger to our future is apathy. Her words resonate as we consider the critical role of oceanic vortexes in fostering biodiversity. As we turn our attention to the future, we find ourselves faced with pressing challenges. Climate change poses a significant threat to the stability of oceanic vortexes. As global temperatures rise, the delicate balance of temperature and salinity is disrupted. The very forces that create these swirling patterns are at risk, and with them, the ecosystems that depend on their stability. Imagine a world where ocean currents falter, where vortexes weaken and dissipate. The consequences could be profound, leading to shifts in marine biodiversity and alterations in weather patterns that affect millions. The urgency to understand and protect these systems has never been greater. Engaging with the complexities of oceanic vortexes invites us to consider our own impact on the planet. How do our actions reverberate through the intricate web of life that the ocean supports? Each choice we make, from our consumption habits to our advocacy for environmental policies, influences the health of the oceans and their swirling currents. As we continue to explore the depths of oceanic vortexes, we invite ourselves into a relationship with the sea that is both respectful and curious. The oceans are alive, and within their depths lie secrets waiting to be uncovered. The swirling vortexes are windows into the dynamic systems that sustain life, urging us to listen and learn from the rhythms of nature. In this pursuit of knowledge, we are reminded of the words of oceanographer Jacques Cousteau. The sea, once it casts its spell, holds one in its net of wonder forever. Each vortex, each movement of water, offers a glimpse into the mysteries of the ocean, calling us to engage with its beauty and complexity. As we delve further into the study of oceanic vortexes, we must embrace a sense of wonder and responsibility. The swirling waters serve as a reminder of the interconnectedness of all living things, urging us to foster a deep respect for the marine environments that are so vital to our planet's health. Reflect on the journey we have embarked upon, exploring the profound significance of these oceanic whirlpools. They are not merely phenomena of nature. They are the heartbeat of the ocean, a crucial element in the delicate balance of life on Earth. As we continue to unravel the mysteries of oceanic vortexes, we are reminded of our place within this majestic system and the importance of safeguarding it for future generations. With each wave that laps against the shore, we are invited to ponder the lessons the ocean has to teach us. The beauty of oceanic vortexes lies not just in their swirling forms, but in the stories they tell about life's resilience, the power of nature, and the importance of stewardship. As we stand at the edge of the sea, let us embrace this journey of discovery with open hearts and minds, ready to learn from the wonders that lie beneath the surface. Chapter 2: How Oceanic Vortexes Form. The formation of oceanic vortexes is a fascinating interplay of natural forces, and at the heart of this phenomenon are the intricate wind patterns that sweep across the oceans. When we think about wind, we often associate it with gentle breezes or fierce storms, but its role in shaping oceanic vortexes is profound. Winds act as the driving force, pushing surface waters and setting them into rotational motion. Imagine the surface of the ocean as a vast canvas, where the winds paint swirling patterns, coaxing the water into beautiful spirals. As the wind blows over the ocean, it transfers energy to the water. This energy does not just cause ripples, it creates larger waves and currents that begin to twist and turn. The strength and direction of the winds are crucial, as they dictate the speed at which water moves and the shape it takes. Think of a child spinning in circles. The faster they spin, the more pronounced their rotation becomes. Similarly, the intensity of the wind can amplify the rotation of water, contributing to the birth of a vortex. Yet, wind alone does not craft these mesmerizing formations. The Earth's rotation plays a pivotal role in this process, a phenomenon known as the Coriolis effect. This effect arises from the fact that the Earth spins on its axis. Picture the planet as a giant spinning top. As it rotates, different latitudes experience varying linear speeds. For instance, the equator spins faster than regions closer to the poles. This difference in speed causes moving objects, including air and water, to deflect to the right in the northern hemisphere and to the left in the southern hemisphere. This deflection is vital for the formation of oceanic vortexes. As winds push surface waters, the Coriolis effect causes these waters to begin spinning, ultimately leading to the formation of distinct vortexes. The interaction between wind and the Earth's rotation creates currents that can spiral tightly or loosely, depending on various factors. Picture a whirlpool in a sink. The water spirals down, creating a vortex. In the ocean, these forces create much larger and more complex systems, with some vortexes spanning hundreds of kilometers. Moving deeper into the ocean, we find that the topography of the ocean floor also influences vortex formation. Beneath the waves lies a landscape of mountains, valleys, and ridges that can interact dynamically with ocean currents. When a current encounters an underwater feature, it can be deflected, causing the water to swirl and spin. This interaction creates localized areas of turbulence, which can strengthen existing vortexes or even give rise to new ones. Imagine a river flowing over a rocky bed. The water tumbles and churns as it navigates the obstacles below. In a similar fashion, ocean currents react to the contours of the seabed. This relationship between topography and water movement is essential for understanding how vortexes evolve and how they can vary in strength and size. Seasonal changes also play a significant role in the life cycle of oceanic vortexes. As the seasons shift, so too do the wind patterns and ocean temperatures. In warmer months, for instance, the sun heats the ocean's surface, causing the water to expand. This warming can lead to changes in density, which affects how currents flow. Consequently, the strength of vortexes can fluctuate dramatically based on seasonal variations. Think of the ocean as a living entity, breathing and changing with the seasons. In the winter, colder air temperatures can intensify certain wind patterns, leading to stronger vortexes. Conversely, during the summer, the gentle winds might create more subtle swirls. The interplay of these seasonal factors determines not only the strength of the vortexes, but also their movement across the ocean. The study of these phenomena has captivated scientists and researchers for centuries. Among them was the renowned oceanographer, Walter Munk, who dedicated much of his life to understanding ocean dynamics. He once stated, "The ocean is a central part of the Earth system, and its dynamics are critical to the understanding of climate." Monk's insights remind us that the swirling waters we observe are more than just beautiful spectacles. They are integral to the broader climate system. As we visualize these powerful forces at play, we might wonder about the implications of oceanic vortexes on marine life. These swirling masses of water are not merely physical formations. They also create unique environments that can support diverse ecosystems. Nutrients are drawn into the vortexes, nourishing phytoplankton and other vital organisms at the base of the marine food web. This relationship illustrates how the intricate dance of physical forces influences life beneath the surface. Moreover, understanding how oceanic vortexes form and behave can offer insights into broader climatic changes. The distribution of heat and nutrients across the oceans affects weather patterns and climate systems worldwide. As vortexes transport warmer waters, they can influence atmospheric conditions, creating ripples that extend far beyond the ocean's surface. Imagine standing on the shore, watching as the waves roll in and out, unaware of the powerful currents swirling beneath. These unseen forces shape our environment in profound ways, reminding us of the interconnectedness of oceanic systems and the life they support. As we explore the dynamic world of oceanic vortexes, we uncover a rich tapestry of interactions. From the gentle caress of the wind to the powerful rotation of our planet, every element plays a vital role in the formation and evolution of these swirling masses of water. The dance of the ocean is intricate and beautiful, a reminder of nature's complexity and the delicate balance that sustains life within its depths. In this vast expanse of blue, where wind meets water and the earth spins beneath, oceanic vortexes emerge as both a mystery and a marvel. They remind us that beneath the surface, a world of wonder is always at play, waiting to be understood and appreciated. The influence of wind patterns on oceanic vortex creation extends beyond mere gusts and breezes. It is a symphony of forces that orchestrate the movement of water. Imagine a vast expanse of ocean, where the winds sweep across the surface, their breath stirring the water into life. This interaction establishes currents, which are not static, but rather dynamic and ever-changing. When we consider the scale of these currents, we begin to grasp the complexity of their formation. Take, for instance, the trade winds, which blow from east to west near the equator. These persistent winds are not just a regional phenomenon, they influence global ocean circulation patterns. As they push water westward, they create areas of convergence and divergence in the ocean. In regions where the trade winds are strong, water piles up, forming a bulge. This accumulation can lead to the development of cyclonic vortexes, where the water begins to spiral as it attempts to return to equilibrium. This concept of equilibrium is fascinating. Why does water seek balance? It is a fundamental principle of nature. Just as a pendulum swings to find its center, ocean waters are constantly adjusting in response to the forces acting upon them. In this quest for balance, vortexes emerge, swirling and twisting as they adapt to the conditions around them. As we extend our understanding of oceanic vortexes, the role of the Earth's rotation cannot be overstated. The Coriolis effect is a crucial player in this intricate drama. Picture the ocean as a vast playground, with the Earth's rotation providing an unseen hand that guides the movement of water. As surface waters are set in motion by the wind, the Coriolis effect acts like a gentle nudge, causing the waters to turn and spiral rather than flow straight. This spiraling motion is not random. It is governed by the laws of physics. The Coriolis effect is most pronounced at higher latitudes, where the deflection of currents becomes more evident. Imagine standing in the northern hemisphere, where a spinning ball of water is inclined to veer to the right. This deflection leads to the formation of large-scale gyres, which are massive systems of rotating ocean currents. The North Atlantic gyre, for example, demonstrates how the interplay of wind, water, and the Earth's rotation creates complex patterns that influence not only marine life, but also climate systems thousands of miles away. As we explore these gyres and the smaller vortexes within them, it's essential to consider how ocean currents interact with the topography of the ocean floor. Beneath the surface lies a three-dimensional landscape that can dramatically alter the flow of water. When currents encounter underwater features, such as seamounts or trenches, they are forced to change direction. This interaction can lead to localized areas of turbulence, creating conditions ripe for vortex formation. Imagine a river coursing over a rocky bed. The water tumbles and swirls as it navigates the obstacles, generating eddies and small whirlpools. In the ocean, a similar process occurs when currents collide with underwater terrain. These interactions can amplify the strength of existing vortexes or create new ones, reshaping the marine landscape. The relationship between ocean currents and topography is a delicate balance. As the currents flow over ridges and valleys, they can also carry with them sediment and nutrients from the ocean floor. These elements are vital for the sustenance of marine ecosystems, providing the building blocks for life in the nutrient-poor open ocean. Vortexes, therefore, act as conduits for these essential materials, drawing them into the swirling waters and distributing them throughout the ocean. As seasons change, the strength and behavior of oceanic vortexes can also shift. The sun's warming rays affect both air and water temperatures, leading to variations in density and current flow. In the spring and summer, warmer surface waters may lead to weaker vortexes as the thermal stratification creates layers that inhibit mixing. However, as autumn approaches and the waters cool, these layers may break down, allowing for the reemergence of stronger vortexes. Consider how the changing seasons not only transform the landscape on land, but also orchestrate a symphony beneath the waves. The ocean responds to these changes with a dynamic rhythm, creating cycles of birth and rebirth in its vortexes. The significance of these seasonal variations extends beyond the physical realm. They have profound implications for marine organisms that depend on the health of these vortexes. The nutrient-rich waters brought about by strong vortexes support burgeoning populations of plankton, which form the bedrock of the marine food web. As the seasons influence the strength of these swirling currents, they ultimately shape the very ecosystems that flourish in the ocean's embrace. In contemplating the intricacies of oceanic vortexes, we might reflect on the words of oceanographer Sylvia Earle, who said, "The ocean is not just a body of water, it is the source of all life." Her insight encapsulates the profound connection between the physical processes that govern the ocean and the vibrant ecosystems that depend on them. As we navigate through this vast world of swirling waters and unseen currents, we come to appreciate the delicate balance of forces at play. The interactions of wind, rotation, topography, and seasonal changes create a mesmerizing dance of motion that shapes not just the ocean's surface, but the very life within it. In this exploration of oceanic vortexes, we find ourselves entranced by the beauty and complexity of nature. Each vortex tells a story of movement, of balance, and of life, reminding us that we are but one part of a larger, interconnected system. The ocean, with its vastness and depth, continues to invite us to learn, to wonder, and to respect the profound forces that shape our world. Chapter 3: Characteristics of Oceanic Vortexes. The ocean is a vast, swirling realm, characterized by its intricate currents and the mesmerizing patterns formed by oceanic vortexes. Within this domain, various distinct types of vortexes emerge, each with its unique features and roles in the marine ecosystem. Among these are eddies, gyres, and rings, each contributing to the ocean's dynamic behavior in fascinating ways. Eddies are like the whimsical dancers of the ocean, small yet powerful. They can form within larger currents, spinning off to create their own miniature whirlpools. Picture a gentle swirl of water, creating a small, rotating pocket that can last from days to weeks. These eddies are often found trailing behind larger currents, like leaves caught in the wake of a flowing river. Their size can vary dramatically, from just a few meters across to several kilometers wide. Eddies play a crucial role in mixing water layers, helping to disperse nutrients and influencing the movement of marine life. It's remarkable to think about how these small whirlpools can significantly impact local ecosystems by redistributing heat and nutrients. Gyres, on the other hand, are the grand, sweeping currents of the oceans. They encompass vast areas, forming large circular patterns due to the Coriolis effect and the influence of wind patterns. Imagine a giant whirlpool, so large that it stretches across entire ocean basins, shaping global ocean currents. There are 5 major gyres that dominate the world's oceans, and each one operates as a colossal conveyor belt, transporting water, heat, and nutrients across vast distances. The North Atlantic Gyre, for instance, not only warms the waters of the eastern United States, but also influences weather patterns across the continent. The presence of gyres is fundamental to the oceanic circulation system, demonstrating the interconnectedness of ocean currents and their climatic effects. Rings, also known as oceanic rings or vortices, are another captivating type of vortex. These structures can form from eddies that become isolated from their parent currents. Imagine a large, swirling mass of water, detached yet still retaining its circular motion. These rings can be warm or cold, significantly affecting local sea temperatures and ecosystems. A warm core ring, for example, can transport warmer water from the tropics into cooler regions, while a cold core ring can have the opposite effect. The ability of these rings to alter local temperatures has profound implications for marine habitats, influencing breeding grounds and migration patterns of various species. The size and lifespan of these vortexes can vary immensely, influenced by factors such as wind conditions, water temperature, and salinity. An eddy might live for just a few days, while larger gyres can persist for years, their influence felt across the globe. As you envision these vortexes, consider how their longevity impacts the ocean's health. Longer-lasting vortexes can sustain ecosystems, providing stable environments for marine life, while transient eddies may create more dynamic and changing habitats. Temperature and salinity gradients within these vortexes add another layer of complexity to their behavior and effects on marine life. As warm surface waters swirl into a vortex, cooler, deeper waters often rise to replace them, creating a mixing effect that enhances nutrient availability. Imagine the vibrant life that thrives in these nutrient-rich upwellings. Phytoplankton, the ocean's primary producers, flourish in these conditions, forming the foundation of the marine food web. The interplay of temperature and salinity within vortexes not only supports marine life, but also influences larger oceanic and atmospheric processes. Satellite imagery has become an invaluable tool for understanding and analyzing the behavior of oceanic vortexes. These breathtaking images capture swirling patterns, revealing the hidden dynamics of the ocean's currents. Imagine looking down from above, witnessing the vibrant blues and greens of the ocean, dotted with the swirling shapes of eddies and rings. The data collected from satellites allows scientists to track these vortexes in real time, providing insights into their movement, size, and temperature variations. One remarkable aspect of satellite imagery is its ability to visualize the intricate interplay of ocean currents. Through these images, we can see how eddies detach from larger currents, or how warm and cold rings interact with surrounding waters. This visual representation not only enhances our understanding of oceanic vortexes, but also aids in predicting weather patterns, ocean circulation, and even climate changes. The ocean, with all its mysteries, is slowly revealing its secrets to us, one image at a time. As we observe these distinct types of vortexes and their characteristics, it becomes clear that they are more than just beautiful formations on the ocean's surface. They are vital players in the grand narrative of Earth's climate and ecosystems, intricately woven into the fabric of ocean dynamics. The more we learn about these phenomena, the more we understand their crucial roles, reminding us of the delicate balance that sustains life in our oceans. Imagine standing on a beach, the salty breeze brushing against your skin as you gaze out at the horizon. Beneath the surface, the currents swirl, moving in harmony with the rhythm of the wind. Each vortex, whether it be an eddy, gyre, or ring, contributes to the ocean's symphony, a melody that resonates through the depths and shapes our planet's climate. In this vast expanse, every swirl, every current tells a story, a narrative of life and movement that continues to unfold. In the grand scheme of things, the study of oceanic vortexes offers a glimpse into the profound interconnectedness of our world. These swirling bodies of water are not isolated phenomena. They are part of a larger system that impacts weather patterns, marine life, and even human activities. As scientists continue to explore and understand these complex structures, we become more equipped to appreciate the ocean's beauty and its vital role in sustaining life. The ocean, in all its vastness, holds secrets waiting to be uncovered. Each vortex is a reminder of the intricate dance of nature, where science and beauty intertwine. In contemplating these incredible characteristics of oceanic vortexes, we find ourselves drawn deeper into the mysteries of the sea, eager to learn and discover more about the world beneath the waves. The essence of oceanic vortexes can be further explored through their distinct characteristics. As we observe the varying types, eddies, gyres, and rings, we discover fascinating details about their size and lifespan. Eddies, for instance, small in scale yet impactful, can spontaneously form and dissipate within a matter of days. Their transient nature provides a snapshot of the ocean's dynamic behavior. In contrast, gyres command attention with their expansive reach, often spanning hundreds of kilometers and persisting for years. Imagine a slow-moving giant, its influence felt across entire ocean basins, shaping not only the water around it, but also the very climate of distant lands. The lifespan of these vortexes is influenced by numerous factors, including wind patterns, ocean temperature, and salinity levels. Each vortex tells a story of its environment, adapting to the conditions that surround it. What do these lifespans reveal about the health of our oceans? Longer-lasting vortexes can indicate stable conditions, offering refuge for marine species, while fleeting eddies may suggest areas of turbulence and change. This delicate balance plays a crucial role in supporting diverse marine ecosystems. Temperature and salinity gradients within vortexes are equally intriguing. As warm surface waters spiral into these formations, they often drag cooler, nutrient-rich waters from the depths, creating a cycle that invigorates life. Picture the vibrant dance of phytoplankton flourishing in such conditions, their growth forming the very foundation of the oceanic food web. These tiny organisms, often invisible to the naked eye, are essential players in the marine ecosystem, sustaining larger species that depend on them for nourishment. Consider the words of marine biologist Sylvia Earle: "No water, no life. No blue, no green." Her insight resonates deeply when we think about the role of vortexes in nutrient distribution. The interplay of temperature and salinity not only affects marine life, but also plays a significant role in the broader oceanic and atmospheric processes. The upwellings generated by these vortexes can lead to areas of high productivity, attracting diverse marine species, from schools of fish to larger predators like whales. Visual patterns of oceanic vortexes captured through satellite imagery reveal even more about their complexity. The artistry of the ocean comes to life in these images, showcasing the swirling colors and shapes that characterize various vortexes. Imagine gazing down from the sky, witnessing the vibrant blues of warm water colliding with the cooler shades of deeper currents, as eddies and rings create a mesmerizing mosaic. This imagery not only provides a feast for the eyes, but serves as a powerful tool for researchers. By analyzing these visual patterns, scientists can track the movement and evolution of vortexes over time. The data gleaned from satellite observations helps to enhance our understanding of ocean dynamics, contributing to improved climate models and predictions. Each image captured is a moment in time, a glimpse into the ever-changing landscape of the sea. The ability to visualize these complex interactions is vital for understanding the ocean's health. What stories do these images tell us about our planet? They reflect the ongoing shifts in climate, the influence of human activities, and the resilience of marine ecosystems. As we interpret these patterns, we gain insights into how vortexes contribute to larger environmental phenomena, such as El Niño and La Niña, which can have far-reaching effects on weather patterns worldwide. Among the remarkable figures in the study of oceanic vortexes is Dr. John Dunn, a climate scientist who emphasizes the importance of understanding these structures in the context of global warming. He states, "The ocean is the beating heart of our planet. Understanding its currents is key to predicting our future." His words underscore how essential it is to perceive vortexes not merely as isolated phenomena, but as integral components of the Earth's climate system. As we continue to explore the characteristics of oceanic vortexes, it becomes evident that they are not merely phenomena to be observed. They are vital elements of our planet's ecosystem. Each vortex, whether a small eddy or a vast gyre, has a role to play in maintaining the balance of marine life and influencing global climate patterns. They remind us of the intricate connections that exist in nature, urging us to appreciate the delicate equilibrium of the ocean. Imagining the ocean as a vast, interconnected web of life, we see how each vortex contributes to the overall health of our planet. The swirling waters beneath the surface are alive with activity, each eddy and ring telling a tale of movement and transformation. As we appreciate the beauty and complexity of these oceanic vortexes, we find ourselves drawn into a deeper understanding of the world around us, eager to learn more about the mysteries that lie beneath the waves. The study of oceanic vortexes invites us to reflect on the larger questions of our existence. How do these swirling masses of water impact our climate and ecosystems? What can they teach us about the delicate balance of life on Earth? As we ponder these questions, we become more attuned to the rhythms of the ocean and the profound connections that bind us to this magnificent blue planet. Each vortex serves as a reminder of the intricate dance of nature, a dance that continues to inspire awe and curiosity in all who seek to understand the sea's depths. Chapter 4: The Role of Vortexes in Ocean Circulation. Ocean currents are the lifeblood of our planet, an intricate system that connects distant shores and influences life in ways we are only beginning to understand. At the heart of these currents lies a phenomenon known as vortexes, swirling masses of water that play a critical role in ushering energy across the ocean. Imagine standing on the edge of a great ocean, feeling the gentle swell beneath your feet, while somewhere deep below the surface, vast currents are spinning in harmony. These vortexes not only contribute to local currents, but are also fundamental to the global ocean circulation system. The connection between vortexes and global ocean currents is both profound and complex. Ocean currents can be likened to a vast conveyor belt, transporting warm water from the equator toward the poles and returning cold water back to the equator. This natural system is driven by various forces, and vortexes act as the engines that help circulate water through this endless loop. Picture a giant whirlpool, its force drawing surrounding water into its depths and pushing it back out in a new direction. This swirling motion allows for a dynamic exchange of heat, nutrients, and gases, fostering a thriving marine ecosystem. One of the most significant impacts of vortexes is seen in thermohaline circulation, sometimes referred to as the ocean's conveyor belt. Thermohaline circulation is driven by differences in water density, which are caused by variations in temperature and salinity. Imagine the ocean as a massive soup pot, where warmer, lighter water sits at the top while cooler, denser water sinks below. Vortexes facilitate this mixing, allowing warmer water to rise and cooler water to descend. This interaction is crucial for the distribution of heat across the planet, influencing weather patterns and climate. The great ocean currents, such as the Gulf Stream, are not merely passive pathways, but are shaped and intensified by vortexes. These currents can have a profound influence on regional climates, particularly in areas like Western Europe, where warm water from the tropics flows northward, moderating temperatures. Without the swirling motion of vortexes, these currents would lose their power, and the climate would be dramatically different. It raises an interesting question. How might our world appear if these currents and their vortexes cease to exist? The answer is a chilling one, as many regions would experience harsher winters and diminished rainfall. As we explore the influence of vortexes on climate patterns globally, we uncover the delicate balance that exists within our planet's systems. Ocean currents are intimately tied to atmospheric conditions, creating feedback loops that can amplify climate effects. For instance, when warm water from the ocean rises into the atmosphere, it can lead to increased humidity and altered weather patterns. The interplay between ocean and atmosphere is a dance of sorts, with vortexes acting as the choreographers, guiding the rhythm of these interactions. Remarkably, scientists have documented how these oceanic vortexes can influence weather phenomena as far away as North America. The warm waters of the Gulf Stream have been observed to affect the development of hurricanes in the Atlantic, as these storms draw on the energy provided by the warm surface waters. As the winds swirl and the ocean churns, we are reminded of the interconnectedness of our natural world. One cannot help but ponder, what other unexpected connections might be hidden beneath the surface of our oceans? Feedback loops between ocean circulation and atmospheric conditions create a dynamic interplay that can lead to both short-term weather changes and long-term climate shifts. The warmth or coolness of ocean waters can affect atmospheric pressure systems, which in turn can alter wind patterns and precipitation. When a vortex strengthens, it can have cascading effects that ripple through the environment, influencing everything from local storms to global climate trends. Consider the El Niño phenomenon, a prime example of how ocean currents can shape weather patterns across the globe. During an El Niño event, the warm waters of the Pacific Ocean shift eastward, disrupting normal weather patterns and leading to extreme weather conditions in various parts of the world. As atmospheric scientists have noted, the ocean is a critical driver of global climate. Vortexes play a key role in this process, as they help to redistribute heat and moisture, ultimately shaping our planet's climate. As we delve deeper into this world of swirling waters and atmospheric interactions, it becomes clear that oceanic vortexes are more than mere curiosities of nature. They are powerful agents of change that influence our environment in ways we are beginning to comprehend. Their intricate connections to global ocean currents, thermohaline circulation, and climate patterns create a web of interactions that highlight the importance of understanding these phenomena. Imagine the vastness of the ocean, a world teeming with life and movement, where even the smallest vortex can have far-reaching effects. As we continue to study these swirling masses of water, we uncover not just their beauty, but their critical role in sustaining life on Earth. The ocean is a complex system, a dynamic realm where every drop of water plays a part in the grand narrative of our planet's climate. The stories told by these vortexes are a reminder of the fragility and interconnectedness of our ecosystem. As we witness the impacts of climate change, understanding the role of ocean circulation becomes ever more vital. The swirling currents that move through our oceans are not just a backdrop to our planet, they are pivotal players in the ongoing story of our climate system. As the great oceanographer Sylvia Earle once said, "No water, no life. No blue, no green." In this context, we begin to appreciate the urgency of protecting our oceans, the incredible vortexes within them, and the delicate balance they maintain. In contemplating the power of vortexes, we are invited to reflect on their significance in our lives. How often do we consider the unseen forces that shape our environment? The swirling waters beneath the surface, the gentle push and pull of currents, quietly dictate the rhythms of life on Earth. As we explore these concepts, we can find a sense of calm in the knowledge that the ocean, with all its mysteries, continues to nurture and sustain us. The role of vortexes in ocean circulation is a testament to the beauty of nature's design, where every element is interconnected and plays a vital part in maintaining the delicate balance of our planet. As we immerse ourselves in the wonders of these swirling waters, let us honor the intricate relationships that exist within our oceanic systems. Each vortex, each current, is a reminder of the forces at play, shaping not just our weather, but the very fabric of life itself. The interplay between vortexes and thermohaline circulation reveals a delicate balance that dictates the distribution of heat and nutrients in our oceans. As warm water moves toward the poles, it cools and becomes denser, eventually sinking into the depths. This process is often compared to a giant, slow-moving conveyor belt that circulates water across the globe. Within this intricate system, vortexes serve as facilitators, ensuring the efficient mixing of water layers. Imagine the ocean as a vast organism, where each vortex acts like a heartbeat, pumping life into its depths, ensuring that the nutrients essential for marine ecosystems are evenly distributed. Furthermore, the role of vortexes extends beyond mere circulation. They also influence climate patterns in ways that are both fascinating and significant. For instance, when we consider the Gulf Stream, its warm waters travel northward, impacting the climate of surrounding regions. The strength and position of this current can shift due to changes in the vortexes along its path, which can lead to alterations in weather patterns. This raises an intriguing question. How might fluctuations in these currents affect seasonal weather across continents? The answer lies in the interconnected web of atmospheric and oceanic dynamics, where even the smallest adjustments can lead to substantial changes in climate. In this context, vortexes contribute to the formation of phenomena such as the North Atlantic Oscillation, a climate pattern that affects weather across Europe and North America. When vortexes are strong, they can create a more stable atmospheric system, leading to milder winters. Conversely, when these vortexes weaken, they can result in extreme weather events, including harsh winters and heavy snowfall. Understanding these relationships helps illuminate the broader implications of ocean circulation on our climate. As we delve further into the ramifications of vortexes on global climate patterns, we are reminded of the work of notable scientists like Wallace Broecker. He famously stated that the climate system is a coupled system, emphasizing the interconnectedness of ocean and atmosphere. This concept is evident in the way vortexes can affect wind patterns, which in turn influence precipitation and temperature across vast regions. When warm ocean waters rise, they can lead to increased evaporation, contributing to more intense storms and altering rainfall patterns. This intricate dance between the ocean and atmosphere highlights the importance of studying vortexes, as they are essential to understanding our planet's climate. Imagine standing beneath a clear sky, feeling the gentle breeze as storm clouds gather in the distance. The energy generated by ocean currents and their vortexes can significantly influence these weather events, transforming a calm day into a tempest. The feedback loops created by these interactions illustrate how sensitive our climate is to changes in ocean circulation. Each vortex, each current, plays a vital role in maintaining the equilibrium of our atmosphere. Moreover, the effects of vortexes extend into the realm of long-term climate shifts. When we consider phenomena such as climate change, the role of ocean currents becomes even more pronounced. As the planet warms, the dynamics of ocean circulation are altered, leading to changes in vortex strength and behavior. This can create a cascade of effects that reverberate throughout the climate system. As researchers continue to explore these relationships, they uncover insights that may help us predict future climate scenarios. The impact of vortexes on thermohaline circulation also raises questions about the resilience of our oceans in the face of climate variability. Are these swirling currents capable of adapting to changes in temperature and salinity? The answer is complex, as vortexes can be both resilient and vulnerable. While they play an essential role in maintaining circulation patterns, they are also susceptible to disruptions caused by human activity and climate change. Consider the implications of a weakened vortex. It is akin to a heart that struggles to pump blood efficiently throughout the body. The consequences can be far-reaching, affecting not just marine ecosystems, but also the atmospheric conditions that govern our weather. As we ponder these connections, we are reminded of the importance of safeguarding our oceans and the intricate systems that reside within them. The relationship between ocean circulation and atmospheric conditions is a reminder of the profound complexity of our planet's systems. Each vortex holds a story, a narrative woven into the fabric of our climate, illustrating the delicate balance that sustains life on Earth. As we deepen our understanding of these swirling waters, we begin to appreciate their role as guardians of our planet's health. In contemplating this vast interconnectedness, we are drawn to the mystery of the ocean itself. With every rise and fall of the tide, there is a reminder of the power and beauty of nature. The ocean's currents, driven by the unseen forces of vortexes, continue to shape our world in ways both subtle and profound. It invites us to reflect on our connection to these waters and the responsibility we bear to protect them. As we continue this exploration, let us embrace the calm that comes from knowing that these vortexes, with their swirling motions and intricate patterns, are not just phenomena to observe, but vital components of the ecosystem that sustains us. The ocean, in all its vastness, continues to inspire wonder and reverence, reminding us that we are part of something much larger than ourselves. Chapter 5: Vortexes and Marine Ecosystems. Vortexes are not merely swirling masses of water. They are the architects of nutrient distribution within the marine environment. As these dynamic formations churn and twist, they create currents that pull nutrients from the deeper layers of the ocean, bringing them to the surface. Picture this process as a grand symphony of life, where the notes are composed of microscopic phytoplankton and essential minerals. These nutrients rise to the sunlight-drenched surface, nourishing a myriad of marine organisms that rely on them for survival. What happens next is a remarkable chain reaction. When nutrients are plentiful, phytoplankton blooms flourish, painting the ocean with vibrant shades of green and blue. These tiny organisms form the foundation of the marine food web, serving as the primary producers that sustain fish populations and larger marine animals. Imagine a thriving underwater garden, teeming with life, where each species plays its role in an interconnected ecosystem. As marine biologist Sylvia Earle once said, "The ocean is a mighty source of life and a powerful force for change." The influence of vortexes extends beyond nutrient distribution. They also shape fish populations and biodiversity hotspots. These areas, rich in life, often coincide with the locations of vortexes. The upwelling currents created by these swirling bodies of water attract schools of fish, drawn by the abundance of food. In turn, larger predators follow, creating a bustling community of marine life. Imagine the thrill of watching a pod of dolphins chase after a school of fish, or witnessing seabirds dive into the water, their wings splashing droplets that glisten in the sunlight. Consider the Gulf of Maine, a region where the interplay of currents and vortexes has given rise to one of the most productive marine ecosystems on the planet. Here, cold, nutrient-rich waters collide with warmer currents, creating an environment that is a sanctuary for diverse species. The rich biodiversity found in this area is a testament to the role of vortexes in promoting life. Is it any wonder that fishermen flock to these waters, their nets brimming with the catch of the day. The ocean's bounty reflects the intricate balance that vortexes help maintain. Vortexes also play a pivotal role in the life cycles of plankton, the minute organisms that drift with the currents. Plankton serves as the backbone of marine ecosystems, and their survival is intricately linked to the dynamics of vortexes. When a vortex forms, it can create areas of calm within the surrounding turbulence. These calmer waters provide a refuge for plankton to thrive, reproduce, and grow. Imagine a small child playing in a gentle eddy, safe from the stronger currents that swirl around them. In this sanctuary, plankton populations can flourish, setting the stage for a diverse array of marine life. One fascinating aspect of plankton is their remarkable ability to harness sunlight through photosynthesis. Just as plants on land convert sunlight into energy, phytoplankton do the same in the ocean. This process not only fuels their growth, but also contributes to the overall health of the planet. In fact, it is estimated that phytoplankton produce half of Earth's oxygen. As we explore the depths of the ocean, we must pause and consider the significance of these minuscule organisms. Their existence is a testament to the interconnectedness of all life on Earth. Case studies of ecosystems thriving around vortexes reveal the profound impact these swirling waters can have on marine biodiversity. One such example is the California current, where the interaction of wind patterns and ocean temperatures creates a series of vortexes that enhance nutrient upwelling. This dynamic system supports a rich tapestry of marine life, from vibrant kelp forests to bustling fish communities. Imagine diving into these underwater jungles, where sunlight filters through the leaves and colorful fish dart among the swaying fronds. Another compelling case is found in the waters off the coast of Africa, where the Agulhas current generates a series of vortices that spill nutrient-rich waters into the Indian Ocean. These vortexes support a diverse array of species, including migratory fish, sea turtles, and even whales. The meeting of warm and cold currents here creates a rich feeding ground, drawing in creatures from far and wide. Picture the majesty of a whale breaching the surface, a powerful reminder of the interconnectedness of the ocean and its inhabitants. The relationship between vortexes and marine ecosystems is a testament to the delicate balance of nature. As these currents swirl and churn, they create environments that foster life and promote biodiversity. Without vortexes, entire ecosystems could falter, unable to access the nutrients they need to survive. As we continue to explore the ocean's depths, we must remain mindful of the intricate connections that exist beneath the surface. Each vortex, each swirl of water, plays a role in a much larger narrative, one that encompasses not only the lives of marine organisms, but also the health of our planet. Imagine the vast expanse of the ocean, a world teeming with life, its rhythms dictated by the powerful forces of nature. In this journey through the ocean's depths, we uncover the significance of vortexes in shaping marine ecosystems. They are not just swirling masses of water, they are essential players in the ongoing story of life beneath the waves. As we move forward, let us keep our hearts and minds open to the wonders that lie within, embracing the beauty and complexity that define our oceans. As we explore further, we can appreciate how vortexes act as conduits of life, facilitating rich interactions among various marine species. The swirling waters not only enhance nutrient distribution, but also create unique habitats. These habitats are often characterized by their rich biodiversity, which can flourish in the areas influenced by vortexes. One particularly compelling aspect of this interplay is the role of vortexes in the migration patterns of marine species. Many fish and marine mammals rely on these currents to guide them through vast oceanic expanses. Imagine a school of herring, their silvery bodies shimmering as they ride the currents, using the vortexes to conserve energy as they travel. This strategic use of oceanic highways underscores the importance of these swirling formations in the life cycles of many species. The relationship between vortexes and marine life is beautifully exemplified by the phenomenon of fish spawning. Certain species time their reproductive cycles to coincide with the upwelling of nutrient-rich waters, which vortexes facilitate. This synchronization ensures that their offspring have access to a bountiful food supply as they emerge into the world. Picture the ocean as a nurturing cradle, where the vibrations of life resonate through the waters, ensuring the continuity of species. Moreover, the biodiversity hotspots that form around vortexes are not merely a product of nutrient availability. They are also influenced by the physical structure of the vortex itself. The circular motion creates distinct microenvironments where different species can thrive. For instance, the edges of a vortex may have varying temperatures and salinity levels, making them ideal for certain types of fish and marine invertebrates. These areas become bustling marketplaces of life, where competition for resources drives evolution and adaptation. Consider the famous upwelling zones off the coasts of Peru and California, where the convergence of oceanic currents creates extraordinary biological productivity. These regions, often characterized by rich marine life, serve as crucial feeding grounds for seabirds, whales, and countless fish species. Imagine standing on a cliff watching flocks of birds swoop down to catch their meals, while beneath the surface, a diverse community of species thrives in this vibrant ecosystem. Plankton, always at the heart of the marine food web, also exhibit fascinating adaptations to thrive within vortexes. Some species of plankton have evolved to utilize the swirling waters to transport themselves to optimal depths, where they can maximize their exposure to sunlight. Others may exhibit behaviors that allow them to remain suspended in the water column, taking full advantage of the nutrient influx that vortexes provide. This intricate choreography of life in the ocean speaks to the resilience of species in harnessing their environment. As we delve into specific case studies, one remarkable example emerges from the waters of the Antarctic. Here, the Antarctic circumpolar current creates a series of vortexes that support an abundance of marine life, including krill, which play a crucial role in the Southern Ocean ecosystem. These tiny crustaceans are not only a primary food source for larger animals, such as seals and penguins, but they also contribute significantly to the ocean's carbon cycle. Envision a sea teeming with life, where krill swarm like clouds, sustaining an entire ecosystem's health. Investigating the North Atlantic, we find similar patterns of life woven around vortexes. The Gulf Stream, with its warm waters, fosters significant biological productivity as it interacts with colder currents. The rich nutrient mix encourages the growth of phytoplankton, which, in turn, supports an array of fish species, including iconic ones like cod and haddock. Imagine the fishermen casting their nets into these vibrant waters, their livelihoods intricately tied to the cycles dictated by oceanic vortexes. The Gulf of Maine, previously mentioned, serves as yet another case study of how vortexes create thriving ecosystems. The convergence of cold and warm waters yields a dynamic environment that supports a diverse array of marine species. Here, the interaction of nutrient-rich upwellings with coastal habitats leads to flourishing kelp forests and thriving coral reefs. Picture a diver exploring these underwater realms, surrounded by a vibrant explosion of colors and life. In each of these ecosystems, the vortexes act as life-giving forces, facilitating a delicate balance that nurtures biodiversity. They reveal the ocean's hidden treasures, reminding us of the intricate relationships that define life beneath the surface. As we contemplate these interactions, we are invited to reflect on the profound impact of vortexes, not just as physical phenomena, but as crucial elements that sustain the life of our oceans. In the expanse of the ocean, where currents swirl and life flourishes, the narrative of vortexes continues to unfold. Each eddy, each swirl of water, plays a role in the larger story of marine ecosystems. The beauty of this interplay speaks to the resilience of nature, a symphony of life that thrives amidst the challenges of the ever-changing ocean. As we draw closer to understanding these aquatic wonders, we find ourselves embracing the mysteries and marvels that the ocean holds within its depths. As we immerse ourselves further into the world of vortexes, we begin to appreciate their role in sustaining the delicate balance of marine ecosystems. The swirling waters not only redistribute nutrients, but also create unique thermal gradients that influence species distribution. Imagine the way warm and cold waters intermingle, each temperature zone offering a distinct array of habitats. This dynamic interaction fosters diversity, allowing varying species to coexist in a symbiotic relationship, each relying on the other for survival. The phenomenon of upwelling, closely associated with vortexes, is particularly fascinating. In regions where winds push surface waters away, deeper waters rise to fill the void. This process not only brings nutrients to the surface, but also creates a thriving environment for larger marine organisms. Picture a rich underwater landscape, where schools of tuna and mackerel feast on the abundant plankton, their bodies glistening in the sunlight filtering through the waves. This cycle of nourishment continues upward, sustaining the majestic creatures that roam the ocean depths. Vortexes also play a crucial role in the intricate dance of predator and prey. As fish gather around these nutrient-rich areas, they attract larger predators such as sharks and larger species of tuna. The resulting feeding frenzy can be a breathtaking spectacle, a reminder of the raw power and beauty of nature. Imagine witnessing the swift, graceful movements of a marlin slicing through the water, its keen instincts honed by eons of evolution. In the case of the North Atlantic, the development of vortexes has been documented to bolster fish populations, providing a vital habitat for spawning and nursery grounds. The convergence of currents creates ideal conditions for various species, including cod and haddock, to thrive. These areas become bustling hubs of activity, where life flourishes, and the interconnectedness of oceanic ecosystems is on full display. Moreover, the influence of vortexes extends to the health of coral reefs. These vibrant structures rely on the nutrient flows generated by surrounding currents. The intricate relationship between vortexes and coral ecosystems fosters biodiversity, allowing various species of fish, invertebrates, and algae to flourish in this dynamic environment. Visualize a coral reef alive with color, where the gentle sway of sea fans and the darting of small fish create a harmonious tableau, all supported by the invisible currents of life flowing around them. In addition to their ecological significance, vortexes are also a key factor in the ocean's ability to sequester carbon. The upwelling of nutrient-rich waters stimulates phytoplankton growth, which in turn captures carbon dioxide from the atmosphere. This natural process acts as a buffer against climate change, showcasing the ocean's vital role in regulating our planet's climate. Imagine the vast expanse of the ocean, a living entity that breathes and interacts with the atmosphere, a silent guardian against the forces of change. As we delve deeper into the world of vortexes, we can also consider the challenges they face. The effects of climate change, pollution, and overfishing threaten to disrupt these delicate ecosystems. Altered wind patterns and rising ocean temperatures can impact the formation and stability of vortexes, potentially leading to a decline in biodiversity and the collapse of local fisheries. It is a sobering reminder of our interconnectedness with the ocean. By understanding the role of vortexes within marine ecosystems, we can appreciate the importance of preserving these vital processes. They are not merely physical phenomena. They are lifelines that sustain countless species and support the health of our planet. As we continue to explore the ocean's depths, let us remain mindful of the delicate balance that vortexes help maintain and the responsibility we bear in protecting this intricate web of life. Thus, as we journey through this mesmerizing world, we come to realize that every aspect of the ocean is interconnected. The swirling vortexes serve as reminders of nature's resilience and its capacity for renewal. Each cycle of nutrient distribution, each shift in predator and prey dynamics, paints a picture of life that continually adapts and evolves. The ocean, in all its complexity, invites us to marvel at its wonders while acknowledging our role in its stewardship. Chapter 6: The Impact of Climate Change on Vortexes. The warming of our oceans has begun to alter the very fabric of oceanic vortex formation. As temperatures rise, the delicate balance that governs the creation of these swirling bodies of water is disrupted. Imagine the ocean as a great cauldron, simmering under the sun's relentless gaze. The heat penetrates the surface, affecting the water's density and its capacity to hold essential nutrients. This change can result in a shift in the patterns and locations where vortexes typically form. The retreat of polar ice and the warming of equatorial waters lead to a redistribution of energy within the ocean. As warm water expands, it can create less dense layers atop cooler, deeper waters, altering the dynamics of how vortexes spin into existence. Picture a pot of boiling water. The heat at the bottom creates bubbles that rise, yet the surface tension keeps them contained. As the water heats, those bubbles change, forming larger ones that may escape into the open air. Similarly, the new conditions may give rise to vortexes that are either weaker or stronger, depending on the interplay of factors at any given time. Furthermore, the strength and frequency of these vortexes are also undergoing significant transformation. The once predictable patterns of vortex creation are now marked by fluctuations. Some regions may experience a surge in vortex activity, while others may witness a stark decline. The implications of this are profound. When vortexes become stronger, they can intensify the transport of warm water, heat, and nutrients across the oceans, potentially disrupting established marine ecosystems. Conversely, a decrease in vortex strength may lead to stagnation, leaving nutrient-rich waters trapped below the surface, inaccessible to the life that depends on them. Such changes are not merely theoretical. They have tangible effects on marine biodiversity and the fishing industries that rely on these ecosystems. As vortexes influence nutrient distribution, they directly impact the abundance and diversity of marine life. Imagine a thriving school of fish darting through the currents that swirl around a vibrant underwater garden, fueled by the nutrients brought forth by a well-formed vortex. If that vortex weakens, the very foundation of their habitat may begin to crumble. Fish populations are sensitive to such shifts, as they depend on a delicate balance of nutrients to thrive. The cascading effects of altered vortex activity can lead to changes in fish migration patterns, reproductive success, and even the collapse of local fisheries. Consider how fishermen rely on the predictable patterns of fish behavior, often guided by the cycles of nutrient availability that vortexes provide. As these patterns shift, so too does the livelihood of coastal communities that depend on fishing to sustain themselves. Renowned marine ecologist Daniel Pauly once noted the fragility of oceanic systems, emphasizing, "We are witnessing a massive decline in the catch of fish, and we are losing the ability to predict where they will be." This sentiment resonates deeply as we witness the unfolding consequences of climate change on vortex activity. As we look to the future, predictions for oceanic vortex behavior become increasingly complex. Climate models suggest that the ongoing warming of the oceans will lead to a variety of scenarios, some of which are difficult to fathom. Will vortexes become more erratic, leading to unpredictable shifts in marine ecosystems? Or will they stabilize in new patterns, adapting to a warmer world? Imagining the future of these swirling currents invites us to consider the intricate web of life they support. The potential for increased extreme weather events also looms large. As vortexes become more dynamic, they may influence not only marine life, but also weather patterns far beyond the ocean's edge. Picture a powerful storm, its energy drawing upon the swirling vortexes below. The interplay between these oceanic phenomena and atmospheric conditions could lead to more intense hurricanes and unpredictable weather, impacting millions of lives far from the coast. In this landscape of uncertainty, scientists continue to seek answers, employing advanced technologies and innovative methods to monitor and predict changes in oceanic systems. The use of satellite imagery, autonomous underwater vehicles, and sophisticated computer modeling allows researchers to gather data that can illuminate the pathways of vortex evolution. Imagine the bright screens of scientists analyzing vast amounts of information, piecing together the intricate puzzle of ocean behavior. The knowledge they glean not only informs our understanding of vortex dynamics, but also guides policy decisions that can help mitigate the impacts of climate change on our oceans. As we ponder the far-reaching implications of climate change on oceanic vortexes, we must remember the interconnectedness of all life forms. Each vortex carries with it the potential for life, and as these swirling currents shift, so too does the fate of countless species. The oceans, vast and mysterious, are ever-changing, and their future is intertwined with our own. The choices we make today will resonate through the waters of tomorrow, shaping the vibrant ecosystems that depend on the delicate balance of nature. The intricate interplay of warming oceans is not just an isolated phenomenon, but a catalyst for broader ecological shifts. As we consider the changes in the strength and frequency of vortexes, we can envision a delicate balance being upset. The warming waters have the potential to amplify the energy within these swirling currents, leading to vortexes that may become more powerful than their predecessors. This amplification could create a feedback loop, where stronger vortexes stir up more heat and nutrients, potentially igniting a cycle of rapid change in marine environments. Imagine the ocean as a living entity, constantly adapting to its surroundings. The increased energy from warmer waters can lead to more vigorous vortex formation, much like how a gentle breeze can transform into a tempest. In some regions, this could result in a surge of nutrient-rich waters reaching the surface, promoting blooms of phytoplankton. Yet, in other areas, the effects may be less favorable, with vortexes weakening and nutrients trapped beneath layers of warmer water, effectively sealing them away from the vibrant life that thrives in sunlight. The consequences extend beyond the mere presence or absence of vortexes. When vortexes become erratic, the delicate synchrony between marine species and their habitats can be disrupted. Fish populations, accustomed to certain patterns of nutrient availability, may find themselves in a state of uncertainty. The migratory routes relied upon for spawning and feeding could shift, leading to potential declines in certain species. What does this mean for the fishing industries that depend on stable marine populations? The unpredictability brought on by altered vortex dynamics could challenge fishermen's ability to forecast where fish will congregate. This uncertainty could lead to overfishing in some areas as they chase dwindling stocks, while other regions may experience a sudden increase in species that were once scarce. The balance of the ocean's ecosystems, finely tuned over millennia, is at risk of being irrevocably altered. Some scientists are sounding the alarm about the potential for significant disruptions within marine food webs. As marine ecologist Boris Worm pointed out, the loss of biodiversity is a loss of resilience. In this context, a decline in fish populations not only threatens local economies, but also diminishes the ocean's ability to adapt to climate variability. Healthy ecosystems thrive on diversity, and as vortexes change with the climate, the intricate relationships between species could unravel, leading to unforeseen consequences. Looking ahead, predictions for oceanic vortex behavior present a tapestry of possibilities, each scenario carrying implications for biodiversity and human livelihoods alike. Climate models have evolved, offering glimpses into the future of our oceans. Some projections suggest a gradual stabilization of vortex patterns in response to a warming climate, allowing marine ecosystems to adapt over time. Others, however, warn of increasingly chaotic vortex activity, leading to unpredictable shifts in marine life. Can we envision a future where vortexes become more erratic, giving rise to extreme weather events that extend beyond the ocean's shores? The increasing intensity of storms and hurricanes may be linked to the very vortexes that support marine life. Each storm, fueled by the energy drawn from these swirling waters, could wreak havoc on coastal communities and ecosystems. The potential for more frequent and severe weather patterns invites us to reflect on our relationship with the ocean and the choices we make today. As researchers delve deeper into these complexities, they employ cutting-edge technology to monitor changes in ocean behavior. Satellite observations provide a bird's-eye view of vortex activity, capturing the subtle shifts that might otherwise go unnoticed. Underwater drones venture into the depths, gathering data on temperature, salinity, and nutrient concentrations, revealing the intricate layers of the ocean's currents. Through these innovative methods, scientists strive to unravel the mysteries of vortex evolution. Imagine the vibrant colors on computer screens, representing swirling currents and shifting temperatures, as researchers analyze patterns that could inform our understanding of future ocean health. This ongoing pursuit of knowledge is crucial, not just for our comprehension of marine ecosystems, but also for guiding policy decisions that could mitigate the impacts of climate change. The fate of oceanic vortexes and the myriad life forms they support is inextricably linked to our actions. As we ponder the interconnectedness of all life, we must consider the broader implications of our choices. Each vortex embodies the potential for life, and as these currents shift under the strain of climate change, so too does the delicate balance of marine ecosystems. By understanding the profound impact of climate change on vortexes, we gain insight into the resilience of our oceans. The choices we make today ripple through time, influencing the vibrant ecosystems that we hold dear. As stewards of this planet, we have a responsibility to protect and preserve the delicate threads that bind us to the ocean, ensuring that future generations can experience the beauty and wonder of these swirling waters. As we consider the shifting dynamics of oceanic vortexes, it becomes clear that these changes have profound implications for the future of marine ecosystems. The interplay of temperature, salinity, and ocean currents creates a complex web that supports a diverse array of life. Yet, with the warming oceans, this web is becoming increasingly fragile. Marine biodiversity is intricately linked to the health of oceanic vortexes. Imagine a coral reef, vibrant and teeming with life, thriving in the nutrient-rich waters brought forth by a well-functioning vortex. As these currents shift, so too does the delicate balance that allows these ecosystems to flourish. Coral reefs, often referred to as the rainforests of the sea, depend on stable conditions to survive. Increased temperatures can lead to coral bleaching, a phenomenon that occurs when corals expel the symbiotic algae living in their tissues. This not only affects the corals themselves, but also the myriad of species that rely on them for habitat and sustenance. The fishing industries, too, face unprecedented challenges as vortexes transform. Imagine a fleet of fishing boats, their nets cast into the waters, hoping to catch fish that have followed their traditional migratory paths. With vortexes becoming increasingly unpredictable, those paths are shifting, often leading to empty nets. Fishermen are left to grapple with the consequences of altered nutrient distributions, which can delay the arrival of fish to familiar grounds or push them into unfamiliar territories. This unpredictability can disrupt local economies, threatening the livelihoods of countless families who depend on the sea for their sustenance. Renowned marine biologist and conservationist Sylvia Earle once highlighted the interconnectedness of ocean life, stating that the ocean is a living system. This idea resonates deeply as we explore the consequences of climate change on vortexes. The ripple effects of these changes extend far beyond the waters themselves, affecting entire communities that rely on the ocean's bounty. It's essential to ask ourselves, how can we adapt to these shifts in marine life and ensure that we do not lose the vibrant ecosystems that have sustained us for generations? Predictions for future oceanic vortex behavior are complex and multifaceted. Climate models indicate that while some regions may experience an increase in vortex intensity, others may suffer from a decline in their frequency. Picture a world where vortexes become more erratic, creating a patchwork of thriving and struggling marine zones. This variation could lead to new fishing hotspots, but also to areas that become nearly barren, devoid of the life they once supported. The implications of these changes are not just environmental, they also speak to our role as stewards of the ocean. As researchers seek to understand vortex evolution, they emphasize the importance of sustainable practices. By recognizing the interconnectedness of our actions with ocean health, we can begin to forge pathways toward resilience. What if we embraced innovative approaches to fisheries management, adapting to the emerging patterns of ocean life rather than clinging to outdated practices rooted in tradition? Imagining a future where we harmonize our activities with the rhythms of the ocean invites us to consider how we can mitigate the impacts of climate change on marine ecosystems. By fostering collaboration between scientists, policymakers, and local communities, we can create a comprehensive framework for managing the challenges posed by changing vortex activity. The ocean's currents are an essential part of the Earth's climate system, and as they shift, so too does the foundation of life itself. The choices we make today can either contribute to the degradation of these vital ecosystems or nurture their resilience. As we ponder the fate of oceanic vortexes, we must also reflect on our responsibility to protect and preserve the oceans that cradle such diverse life forms. The swirling waters, with their inherent beauty and complexity, serve as a reminder of the delicate balance that sustains our planet. How we respond to the challenges posed by climate change will echo through time, shaping the future of our oceans and the myriad of species that call them home. Chapter 7: Vortexes and Human Activities. The influence of vortexes on shipping routes and navigation is profound, shaping the very paths that vessels traverse across the oceans. Imagine a ship, gliding through the depths of the sea, navigating the intricate patterns created by these swirling waters. Oceanic vortexes can create zones of calm or turbulence, guiding or challenging the journeys of mariners. For centuries, sailors have relied on their understanding of currents and vortexes to chart their courses, enhancing safety and efficiency. The Gulf Stream, a powerful current, flows from the Gulf of Mexico along the eastern coast of the United States and across the Atlantic Ocean. This current is not merely a stream of warm water. It is a vortex with immense power that influences weather patterns and shipping routes. As vessels harness the current's flow, they can save fuel and time. Picture a captain adjusting their sails to catch the wind, steering their ship with the current's embrace. The knowledge of vortexes becomes an invaluable compass, pointing the way through the vast blue expanse. Yet, vortexes do more than steer ships. They also impact coastal communities and fisheries. The interaction between vortexes and coastal waters creates a dynamic environment where nutrients are plentiful and marine life thrives. Consider coastal fishermen who have long understood the rhythms of the sea. They know that areas where vortexes form often coincide with rich fishing grounds. These swirling waters bring nutrients from the depths, creating a fertile feeding ground for fish. As we envision these bustling communities, it is essential to acknowledge the challenges they face. The delicate balance of marine ecosystems can be disrupted by human activities and climate change. Overfishing, pollution, and habitat destruction pose significant threats to the very vortexes that sustain these fisheries. Imagine standing on a dock, watching as fishermen haul in their catch, their livelihoods intricately linked to the health of the ocean. It is a reminder of the vital relationship between humans and the marine world, a connection that must be nurtured for future generations. The role of vortexes extends further into the realm of pollution dispersion and marine debris management. Picture a floating piece of plastic bobbing on the surface of the water. The fate of this debris is often determined by the swirling currents and vortexes that move through the ocean. These natural phenomena can trap marine debris in gyres, where it accumulates in vast patches, such as the Great Pacific Garbage Patch. As vortexes spin and churn, they can also aid in the dispersion of pollutants. Contaminants released into the ocean are swept away by currents, sometimes causing harm in distant places. Yet, vortexes can also facilitate the breakdown of these pollutants by mixing them with surrounding water, promoting dilution. This highlights the dual nature of vortexes, a force of both accumulation and dispersion. Consider the ongoing efforts to combat marine pollution, where scientists and researchers harness an understanding of vortex dynamics to develop strategies for cleanup. Innovative technologies, such as floating barriers and drones, are being deployed to capture debris in areas where vortexes converge. These initiatives reflect a growing awareness of our impact on the ocean and the necessity of responsible stewardship. Throughout history, there have been remarkable case studies of human-vortex interactions that illustrate both the benefits and challenges posed by these swirling waters. One notable example is the role of vortexes in the devastating oil spills that have occurred over the years. When oil is released into the ocean, the currents and vortexes can either concentrate the spill or disperse it. The infamous Deepwater Horizon spill serves as a stark reminder of this interplay. In the aftermath, researchers observed how the Gulf of Mexico's vortexes influenced the spread of oil, complicating containment and cleanup efforts. The swirling waters became a chaotic dance of disaster, illustrating the profound effects of human activity on marine environments. This case underscores the need for understanding the dynamics of vortexes, as they can transform our responses to environmental crises. Another compelling case study is the use of vortexes in the design of marine protected areas. These areas are crucial for conserving biodiversity and ensuring the health of marine ecosystems. By strategically placing protected zones in locations where vortexes are prevalent, scientists can enhance the resilience of fish populations and promote the recovery of overfished species. Imagine a vibrant marine sanctuary where the waters teem with life, nurtured by the currents that swirl around it. The integration of vortex dynamics into conservation strategies reflects a harmonious approach to managing our ocean resources. These efforts remind us that when we respect and understand the natural systems at play, we can create pathways for both human activity and marine life to thrive. As we contemplate the intricate relationships between vortexes and human activities, we are reminded of the delicate balance required to maintain the health of our oceans. The swirling waters, with their mesmerizing patterns, invite us to reflect on our role as stewards of the sea. How can we ensure that our activities contribute positively to the very ecosystems that sustain us? Exploring these questions leads us deeper into the understanding of vortexes and their interactions with human endeavors. The pursuit of knowledge in this field continues to evolve, shedding light on new ways to coexist with the natural world. By embracing this understanding, we can foster a sustainable future that honors the complexities of the ocean's vortexes, ensuring their beauty and bounty endure for generations to come. The interplay between vortexes and coastal communities is an intricate dance, affecting not only fisheries, but also the very livelihoods of those who call these coastal areas home. These communities have long adapted to the rhythms of the sea, relying on the bounty provided by the ocean's currents. Imagine a bustling harbor where fishermen prepare their nets, each aware of the secrets held within the swirling waters. The proximity to vortexes often means a richer catch, but it also presents challenges as these communities face the impacts of climate change and pollution. As ocean temperatures rise, the dynamics of vortex formation are shifting, leading to changes in fish migration patterns. Species that once thrived in certain areas may relocate in search of cooler waters or altered food availability. This phenomenon raises a crucial question for coastal communities. How can they adapt to the shifting availability of marine resources? Envision fishermen as stewards of the sea, their experience guiding them in navigating these changes, yet also requiring a willingness to innovate and adjust to new realities. The effects of vortexes extend beyond the immediate catch. They also influence the broader ecosystem health. Coastal waters are often rich in biodiversity, but human activities can disrupt this delicate balance. The introduction of pollutants and plastic waste into the ocean creates a stark contrast against the vibrant marine life that vortexes help sustain. Picture a serene beach, the waves lapping gently at the shore, yet beneath the surface, microplastics infiltrate the food chain, threatening the health of fish and, ultimately, the communities that depend on them. To mitigate these challenges, communities are turning to science and technology, seeking ways to harness the power of vortexes for environmental stewardship. Innovative approaches to marine debris management have emerged, with scientists exploring how vortex dynamics can be leveraged to address pollution. By understanding the patterns of currents and vortexes, initiatives can be developed to capture debris before it spreads, protecting marine habitats and preserving the health of fisheries. Consider the role of community-based programs that educate residents about the importance of preserving their marine environment. These initiatives often promote sustainable fishing practices and encourage local stewardship, fostering a sense of responsibility towards the ocean. By engaging with the science of vortexes, communities can better understand the interconnectedness of their actions and the health of their waters. The impact of vortexes is also felt in the realm of tourism, as coastal areas draw visitors seeking the beauty and bounty of the sea. Imagine a picturesque coastline where families gather to enjoy the sun and the surf, each wave a reminder of the ocean's power. However, with increased tourism comes the need for careful management. The influx of visitors can lead to pollution and habitat degradation, threatening the very ecosystems that attract them. As coastal communities strive to balance economic growth with environmental preservation, the role of vortexes in shaping their waters becomes ever more critical. By integrating scientific understanding into tourism practices, they can enhance visitor experiences while promoting conservation efforts. Picture guided eco-tours that teach visitors about the importance of vortexes and their influence on local ecosystems, creating a deeper appreciation for the ocean's wonders. Case studies abound that highlight the resilience of coastal communities facing these challenges. In one instance, a small fishing village near a prominent vortex adopted sustainable fishing practices and collaborated with scientists to monitor fish populations. The result was a rejuvenation of their fisheries, demonstrating the power of community engagement in conservation efforts. These initiatives serve as a reminder that when humans and nature work in harmony, remarkable transformations can occur. As we reflect on the relationship between vortexes and human activities, it becomes evident that understanding these interactions is vital for the health of our oceans. What might the future hold if we embrace the knowledge of how vortexes shape our marine environment? By fostering a culture of sustainability, we can ensure that both marine life and coastal communities flourish. The challenge of pollution dispersion and marine debris management highlights the complexities of human vortex interactions. Vortexes can act as both a bane and a boon in this regard. While they may concentrate pollutants in certain areas, they can also facilitate the dispersal of harmful substances, leading to broader ecological impacts. Imagine the intricate web of life that exists beneath the waves, where every creature plays a role, and yet the introduction of pollutants can unravel this delicate balance. Innovative solutions are being sought to harness the natural dynamics of vortexes in combating marine pollution. Emerging technologies are being developed to track debris using real-time ocean current data, allowing for targeted cleanup efforts. Picture a fleet of drones, gliding above the waves, equipped with sensors that identify areas of concentrated marine debris, guiding cleanup crews to the most affected regions. Furthermore, researchers are exploring how vortexes can be utilized in bioremediation efforts. By understanding the flow patterns of water, scientists can identify optimal locations for deploying bioremediation agents that break down pollutants. This approach exemplifies the potential for human ingenuity to align with nature's processes, fostering a healthier oceanic environment. The stories of those who work on the front lines of marine conservation often inspire hope. From scientists dedicated to researching vortex dynamics to local fishermen who advocate for sustainable practices, these individuals embody the spirit of stewardship. Their tireless efforts remind us that each of us has a role to play in protecting our oceans. As we ponder the intricate relationships between vortexes and human activities, we are beckoned to consider our own responsibilities. How do our choices impact the swirling waters that sustain us? By embracing a mindset of sustainability, we can cultivate a future where both human activities and the health of ocean ecosystems coexist in harmony. The journey of understanding oceanic vortexes and their influence is ongoing, revealing new insights and challenges. Each discovery leads us closer to appreciating the intricate balance of our oceans and the vital role they play in our lives. As we continue to explore these depths, we are reminded that the ocean is not merely a resource to be exploited, but a precious entity to be cherished and protected. Chapter 8: Technological Advances in Vortex Research. The study of oceanic vortexes has entered an exciting new era, driven by technological advances that enhance our ability to observe and understand these powerful phenomena. Imagine standing on the deck of a ship, gazing out at the vast ocean, while above you, satellites orbit the Earth, capturing intricate details of the swirling currents below. This marriage of technology and oceanography has revolutionized how scientists approach the study of vortexes. Satellite technology plays a pivotal role in this transformation. From their vantage point in space, satellites are equipped with sensors that measure sea surface temperature, chlorophyll concentration, and even ocean color. These observations provide a wealth of information about the health of marine ecosystems and the dynamics of oceanic vortexes. For instance, when a satellite detects a rise in sea surface temperature, it can signal the presence of a vortex that may be drawing warmer water from deeper layers. Think of this as a cosmic eye peering down to unveil secrets hidden beneath the surface. Remote sensing technologies have become indispensable tools in the understanding of vortex formation and behavior. Imagine a delicate dance of data as satellites send waves of information back to Earth, revealing the movement of water with remarkable precision. These technologies allow scientists to track the formation of eddies and gyres in real time, enabling them to observe changes that occur due to seasonal variations or climate influences. The ability to monitor these formations from space is akin to having a front-row seat to nature's most captivating performances. However, the study of vortexes does not rely solely on satellite imagery. Computational models have emerged as essential instruments for predicting vortex behavior. These models use complex algorithms to simulate the physical processes that govern ocean dynamics. Picture this: a vast computer network, crunching numbers and simulating the swirling motions of water, generating predictions that can help scientists anticipate how vortexes will evolve over time. By inputting various environmental factors, researchers can create scenarios that explore the impact of changing temperatures, salinity, and wind patterns on vortex formation. Among the pioneers in this field is a group of scientists who have dedicated their lives to unraveling the mysteries of ocean currents. One such individual is a renowned oceanographer who once stated that the ocean is a living organism, a complex and dynamic system that we must learn to understand. This sentiment reflects the collaborative spirit that drives research in vortex studies, as scientists from various disciplines come together to share their expertise and insights. Collaboration is crucial in advancing our understanding of vortexes. Institutions around the world, from universities to government agencies, are pooling resources and knowledge to tackle the complexities of ocean dynamics. Imagine a network of researchers, each contributing their unique skills and perspectives, united by a common goal: to unlock the secrets of the ocean. This collaborative approach enables scientists to merge satellite observations with computational models, creating a comprehensive picture of how vortexes operate within the broader context of ocean circulation. One remarkable example of such collaboration is the development of international research programs aimed at studying the impact of climate change on oceanic vortexes. As scientists investigate how warming temperatures alter the behavior of these formations, they share their findings across borders, fostering a global dialogue on the importance of preserving marine ecosystems. This interconnectedness echoes the very nature of ocean currents, which flow and mingle, influencing one another in an intricate web of life. The symbiotic relationship between technology and oceanic research is not just about observation. It also empowers scientists to make informed predictions that can guide policy decisions. Imagine the potential for creating sustainable fishing practices or developing strategies to protect coastal communities from the impacts of changing ocean dynamics. The data collected through satellite imagery and computational models can inform management practices, ensuring that humanity's relationship with the ocean is one of stewardship and respect. As we consider the advances in vortex research, it is essential to reflect on the profound implications these developments hold for our understanding of the planet. The ability to observe and predict the behavior of oceanic vortexes allows us to appreciate their role not just as isolated phenomena, but as integral components of the global climate system. Each vortex, each swirl of water, is interconnected with the larger currents that influence weather patterns, marine life, and even human activities. Imagine the ocean as a vast library, where each vortex holds a chapter in the ongoing story of our planet. The more we learn about these chapters, the better equipped we are to navigate the challenges posed by climate change and environmental degradation. The technological advancements in vortex research serve as a testament to human ingenuity and our desire to understand the world around us. As we move forward in this exploration, let us embrace the wonder of the oceanic realm, where swirling vortexes continue to captivate our imagination and inspire scientific inquiry. The journey into the depths of ocean dynamics is just beginning, and with each technological advancement, we come closer to unveiling the mysteries that lie beneath the surface. With the tools and techniques at our disposal, the ocean offers a treasure trove of knowledge waiting to be discovered. The tools and techniques available for studying oceanic vortexes are constantly evolving, making the task of understanding these complex systems ever more precise. Among the most remarkable advances in this domain is the integration of satellite technology with in situ measurements. Picture a fleet of vessels equipped with advanced sensors, collecting data from the ocean while satellites hover above, capturing a bird's-eye view of the swirling waters below. This synergy allows for a more comprehensive understanding of vortex dynamics, revealing the ways in which surface conditions relate to deeper oceanic processes. In situ measurements, taken directly from the ocean, provide invaluable data on temperature, salinity, and pressure at various depths. These readings are essential for calibrating satellite observations, ensuring that what is seen from space has a solid foundation in reality. Imagine a scientist on a research vessel lowering a series of buoys into the water, each equipped with sensors that will relay real-time information. These buoys drift, capturing the essence of the ocean's currents, and contribute to a more detailed portrait of the vortexes at play. The process of gathering data has been transformed by the use of autonomous underwater vehicles. These remarkable machines can dive deep into the ocean, exploring areas that are otherwise difficult to reach. They collect data with precision, gliding through currents while sending back information on temperature gradients and water composition. As these vehicles navigate the depths, they reveal hidden layers of the ocean, shedding light on the interactions occurring beneath the surface. Imagine them as curious explorers, venturing into the dark, mysterious realms of the sea, uncovering secrets that have long remained uncharted. Yet, the sheer volume of data generated by these technologies can be overwhelming. This is where computational models come into play, turning raw data into actionable insight. By employing sophisticated algorithms, researchers can simulate vortex behavior under various conditions, predicting future states based on current observations. Envision a vast digital ocean, where every parameter is meticulously mapped, allowing scientists to visualize potential outcomes of vortex interactions. With these models, they can simulate the impacts of climate change, analyzing how shifting temperatures and salinity levels may alter the formation and strength of vortexes. One notable figure in this field is a leading oceanographer known for his work in ocean modeling. He asserts that the models we create are not just abstractions, they are essential tools that help us understand the ocean's complex behaviors. This perspective highlights the importance of marrying theoretical knowledge with empirical data, a partnership that fuels scientific discovery. Collaboration between institutions and scientists is another cornerstone of progress in vortex research. Imagine a world where researchers from different continents come together, united by a shared passion for ocean exploration. This collaborative spirit fosters an exchange of ideas and resources, enhancing the quality of research and accelerating discoveries. International workshops and conferences serve as platforms for sharing findings, where scientists present their latest research and discuss advancements in vortex studies. One exemplary initiative is a global research consortium that brings together oceanographers, climate scientists, and data analysts. This consortium focuses on understanding the multifaceted impacts of vortexes on ocean health and climate systems. Through joint projects, they pool their expertise to tackle pressing questions, such as how vortexes affect carbon cycling or influence migratory patterns of marine species. Such collaborations not only bolster scientific knowledge, but also promote a sense of global stewardship for our oceans. The importance of interdisciplinary cooperation cannot be overstated. By engaging experts from various fields, such as physics, biology, and environmental science, researchers can develop a holistic understanding of oceanic vortexes. This integrative approach allows for the examination of vortexes as part of larger ecological networks, recognizing the interdependencies between physical oceanography and marine biology. Imagine a web of knowledge, where insights from one discipline illuminate aspects of another, leading to breakthroughs that deepen our understanding of ocean dynamics. As we continue to explore the technological advances in vortex research, it becomes clear that the tools and techniques we employ are not just enhancing our knowledge, they are reshaping our relationship with the ocean. The ability to observe and predict the behavior of vortexes empowers us to make informed decisions about marine conservation and resource management. Consider the implications of this knowledge. By understanding how vortexes influence nutrient distribution and marine life, we can better protect fragile ecosystems and ensure sustainable practices. Reflecting on these advancements, it is essential to recognize the profound connection we share with the ocean. Each technological leap not only expands our understanding, but also deepens our responsibility to protect this vast, life-sustaining body of water. The ocean, with its mesmerizing vortexes, invites us to engage in a continuous dialogue about our role in its preservation. As we harness these advancements, let us also cultivate a sense of wonder and respect for the intricate systems that lie beneath the surface. Through this journey of discovery, we illuminate the path forward, where technology and nature work in harmony. Each new insight into the behavior of oceanic vortexes not only enriches our scientific knowledge, but also serves as a reminder of the beauty and complexity of the world we inhabit. The ocean continues to inspire, calling upon us to explore its depths and cherish the delicate balance of life it supports. As we embrace these technological advances, we are reminded of the timeless truth that the ocean is both a source of knowledge and a sanctuary of life. As we explore the technological advances in vortex research, we begin to appreciate how these innovations extend beyond mere observation. The integration of artificial intelligence and machine learning into data analysis has opened new vistas of understanding. Envision a system capable of learning from vast datasets, identifying patterns that elude even the most seasoned oceanographers. This technology empowers researchers to refine their models of vortex behavior, transforming raw data into predictive tools that can anticipate changes in ocean dynamics with remarkable accuracy. Consider the implications of harnessing such technology. Scientists can now delve into simulations that encompass myriad variables, from ocean temperatures to atmospheric conditions, effectively painting a more detailed picture of how vortexes might evolve. The ability to visualize potential scenarios in real time enables a proactive approach to understanding and responding to the complexities of oceanic phenomena. These advanced algorithms are like a guiding compass, steering researchers through the intricate landscape of oceanic behavior. Furthermore, the convergence of satellite data and machine learning algorithms allows for enhanced monitoring of vortex activity. Imagine a network of satellites continuously scanning the ocean, sending streams of information back to Earth, where algorithms process this data to detect and classify vortexes as they form. This dynamic interplay not only assists in tracking vortex development, but also aids in understanding their impact on surrounding ecosystems. The knowledge gleaned from such systems can be instrumental in forecasting marine events, such as harmful algal blooms or shifts in fish migration patterns, enabling timely interventions to protect marine life. The role of interdisciplinary collaboration cannot be overstated in this context. Scientists, engineers, and data analysts are joining forces to create a more holistic approach to oceanic research. Picture a vibrant ecosystem of ideas where experts from diverse fields contribute their insights to foster innovation. This synergy enhances the depth of understanding, as each discipline brings a unique perspective to the challenges posed by oceanic vortexes. One significant initiative exemplifying this collaborative spirit is the development of joint research platforms that facilitate data sharing among institutions globally. Through these platforms, researchers can access a wealth of information, enriching their studies and broadening their scope. Imagine a virtual hub where oceanographers from different continents share their findings in real time, working together to analyze the implications of vortex interactions on climate change and marine biodiversity. This global exchange is indicative of a new era in ocean science, where boundaries dissolve in the pursuit of knowledge. The societal implications of these technological advancements are profound. With improved understanding of oceanic vortexes, we can advocate for policies that promote sustainable practices in marine resource management. Imagine coastal communities equipped with predictive tools that allow them to anticipate changes in local fisheries as vortexes shift nutrient distributions. Armed with this knowledge, these communities can adapt their practices, ensuring their livelihoods are resilient in the face of environmental changes. In this new age of vortex research, we find ourselves at a crossroads between technology and nature. As each advancement unfolds, we gain deeper insights into the ocean's mysteries, echoing the sentiment of one notable ocean scientist who remarked on the interconnectedness of life and the ocean. This understanding fosters a sense of stewardship, urging us to protect the delicate balance that sustains both marine ecosystems and human communities. In summary, the journey of discovery in vortex research is illuminated by the light of technological advancement. The synergy of satellite observations, in situ measurements, machine learning, and interdisciplinary collaboration paints a rich and detailed portrait of oceanic dynamics. As we strive for deeper knowledge, we are reminded of the ocean's vast potential, calling us to cherish and protect this vital resource that nurtures life on Earth. The ocean, with its swirling vortexes and hidden depths, continues to inspire our quest for understanding, beckoning us to explore further into its vast embrace. Chapter 9: The Future of Oceanic Vortex Research. The realm of oceanic vortex research stands at a crossroads, where emerging questions and challenges beckon scientists to deepen their understanding. As we gaze into the future, we may wonder, what new mysteries lie beneath the surface of these swirling phenomena? The dynamic interplay of climate change, human activity, and technological advances creates a landscape rich with intrigue and uncertainty. How do we adapt our research to address these evolving challenges? One of the most pressing questions revolves around the impact of changing ocean temperatures on vortex formation. As observed in previous chapters, rising sea temperatures modify the density gradients that drive vortex development. Imagine the ocean as a living entity, its temperament shifting with the seasons, its swirling currents responding to the warmth of the sun. Researchers must now focus on how these altered conditions may lead to the emergence of new types of vortexes or the transformation of existing ones. Will we witness vortexes that are more intense, potentially wreaking havoc on ecosystems and weather patterns? Or perhaps we will see the birth of subtler, more intricate formations that challenge our current understanding. Moreover, the challenge of scaling up our models to encompass the vastness of the ocean cannot be understated. How do scientists capture the complexity of vortex dynamics when faced with the sheer enormity of the ocean? This is where interdisciplinary approaches come into play. Collaboration among oceanographers, climatologists, biologists, and even social scientists can lead to a holistic understanding of vortex behaviors. Picture a team of scientists, each bringing their unique expertise to the table, uniting their knowledge like the threads of a finely woven fabric. Together, they explore the intersections of ocean currents and atmospheric phenomena, unraveling the mysteries that govern our planet's climate. As we consider these collaborative efforts, the potential breakthroughs in understanding climate impacts become evident. Oceanic vortexes are not isolated entities. Their influence reaches far beyond local waters, affecting global weather systems and climate patterns. Imagine a vast network of interconnected currents, each vortex contributing to the greater whole, shaping weather patterns in distant regions. By comprehensively studying these interactions, scientists can provide critical insights into how climate change may alter storm patterns, sea level rise, and even the migration of marine species. The importance of public awareness and education cannot be overlooked in this journey. How do we communicate the significance of oceanic vortexes to a world that may not fully grasp their impact? Engaging storytelling can transform complex scientific concepts into relatable narratives. Imagine a classroom where children are captivated by tales of swirling waters and the creatures that thrive within them, igniting a spark of curiosity that fosters a new generation of ocean advocates. By nurturing this connection between people and the ocean, we cultivate a collective responsibility to protect these vital ecosystems. Educators and scientists alike can harness technology to enhance public understanding. Interactive platforms, documentaries, and community-based projects can bridge the gap between research and the public. Consider a virtual reality experience that immerses participants in the heart of an oceanic vortex, allowing them to witness firsthand the beauty and complexity of these formations. Such tools can evoke a sense of wonder and urgency, motivating individuals to engage with ocean conservation efforts. As we look forward, the future of oceanic vortex research brims with possibilities. The questions we encounter today will shape the course of tomorrow's discoveries. By embracing interdisciplinary collaboration, harnessing technology, and fostering public awareness, we can illuminate the path ahead. The swirling waters of the ocean continue to hold secrets, inviting us to explore, understand, and protect the life they sustain. What marvels will we uncover as we venture further into this captivating domain? The ocean, with its vast mysteries, awaits our inquiry. As we peer into the depths of oceanic vortex research, it becomes clear that the questions facing us are not just scientific curiosities. They hold the key to our understanding of a rapidly changing planet. One pressing inquiry revolves around the role of human activity in altering the very nature of these vortexes. What happens when industrial runoff, plastic pollution, and climate change collide within the oceanic dance of currents? In this complex interplay, vortexes can serve as both indicators and amplifiers of human impact. Imagine a vortex as a magnifying glass, focusing the effects of pollution into specific areas where they can wreak havoc on marine ecosystems. These swirling waters can concentrate pollutants such as microplastics and harmful chemicals, leading to local hotspots of toxicity. Marine life, entangled in this web of swirling currents, may face dire consequences. Species that rely on nutrient-rich waters may find their environments compromised, leading to declines in populations and shifts in biodiversity. How will this affect the fragile balance of marine ecosystems? The implications are vast and far-reaching. This brings us to the necessity for interdisciplinary collaboration among scientists, policymakers, and communities. By combining expertise from oceanography, environmental science, and social sciences, we can forge a comprehensive understanding of how vortexes interact with human activities. For instance, marine biologists can work alongside oceanographers to study the impacts of vortex-induced nutrient distribution on fish populations, while environmentalists can advocate for policies aimed at reducing pollution. Picture a group of researchers, each armed with their unique insights, coming together to craft strategies that protect the oceans, fostering resilience in the face of adversity. As our understanding of these interactions deepens, we may uncover potential breakthroughs that illuminate the relationship between oceanic vortexes and climate change. The swirling currents do not exist in isolation. They are part of a greater system that governs global climate. For example, researchers have begun exploring how changes in vortex strength and frequency might influence the distribution of heat across the oceans. By using advanced computational models, scientists can simulate various scenarios, offering glimpses into the future of our planet's climate. Imagine a world where we can predict shifts in weather patterns or the migration of marine species, guided by the behavior of oceanic vortexes. What if we could anticipate the arrival of storms or shifts in fish populations, allowing us to adapt our practices for sustainable resource management? The importance of educating the public about these complex interactions cannot be overstated. As we navigate the challenges ahead, a well-informed populace will be essential for driving change. How do we transform intricate scientific findings into compelling narratives that resonate with people? Engaging storytelling can play a vital role in this process. Imagine a documentary that follows scientists as they study vortexes, weaving together their discoveries with the stories of fishermen whose livelihoods depend on healthy oceans. Such narratives can inspire empathy and urgency, urging individuals to take action for the preservation of marine environments. Moreover, technology continues to be a bridge between scientific research and public engagement. With the rise of social media and online platforms, scientists have the opportunity to share their findings in real time, reaching audiences far beyond academic circles. Interactive online tools can allow individuals to visualize the effects of vortexes on their local waters, fostering a personal connection to the ocean. As we think about the future, consider the potential of citizen science initiatives, where everyday people contribute to our understanding of oceanic vortexes. How might their observations enrich our knowledge and foster a sense of stewardship for the marine environment? As we forge ahead into the future of oceanic vortex research, the confluence of curiosity, collaboration, and education will be our guiding stars. The questions posed today will pave the way for innovative discoveries, shaping not only our understanding of oceanic vortexes, but also our relationship with the oceans themselves. The ocean remains a realm of wonder, brimming with secrets waiting to be uncovered. How will we rise to meet the challenges that lie ahead? The swirling currents invite us to dive deeper, to learn, and to protect the life that thrives within their embrace. The inquiries into the dynamics of oceanic vortexes lead us to ponder their potential role as indicators of ecological health. As scientists delve into the intricate mechanics of these swirling currents, they begin to recognize how vortexes can reflect the broader conditions of the marine environment. Are these vortices merely physical phenomena, or do they hold the key to understanding the health of our oceans? By observing changes in their behavior, such as shifts in strength or frequency, researchers can glean insights into the effects of climate change and human activities. Consider the fluctuations in vortex patterns as a symphony, with each note representing a vital aspect of the ocean's ecosystem. When these notes are out of tune, it signals impending changes that may affect marine life. For instance, a significant alteration in the size or intensity of a vortex may correlate with shifts in fish populations or changes in nutrient distribution. It raises the question: how well can we read this symphony, and what does it tell us about the world beneath the waves? In this intricate dance of data, the potential breakthroughs become increasingly compelling. Imagine a future where advanced algorithms and machine learning can analyze vast datasets from satellites and sensors, interpreting the subtle shifts in vortex dynamics to predict changes in marine ecosystems. In the words of a notable scientist, the future of research lies in our ability to harness the power of big data. What if this capability allowed us to foresee the consequences of environmental shifts before they manifest, guiding our conservation efforts with precision? The future of oceanic vortex research also hinges on the integration of indigenous knowledge alongside modern scientific inquiry. For centuries, coastal communities have observed the patterns of the ocean, passing down wisdom about the behavior of currents and their relation to marine life. This traditional ecological knowledge, when coupled with contemporary science, can enrich our understanding of vortex dynamics. How might these ancient insights illuminate the complexities of vortex formation in ways that contemporary research alone cannot? As we contemplate the significance of these collaborative approaches, the importance of public awareness and education emerges as a vital thread in the fabric of vortex research. How do we cultivate an informed public that not only understands these phenomena, but also feels empowered to protect them? Engaging young minds in the wonders of ocean science can ignite a passion for marine conservation. Imagine children, eyes wide with wonder, learning about the swirling currents that sustain life in the ocean, fostering a generation of advocates who will champion the health of our seas. Educational initiatives must extend beyond the classroom. Community outreach programs can bridge the gap between scientific research and public engagement, creating opportunities for individuals to participate actively in ocean conservation efforts. Picture a local beach cleanup where families come together, not only to remove debris, but also to learn about the impact of pollution on vortex dynamics and marine ecosystems. Such experiences can inspire a sense of stewardship, nurturing a collective responsibility to safeguard the ocean's health for future generations. In this journey toward understanding, technology remains a powerful ally. As we harness the capabilities of virtual reality, interactive simulations, and social media, we can create immersive experiences that bring the ocean's wonders to life. Envision a virtual tour through an oceanic vortex, where participants can experience the swirling waters and the intricate life forms that depend on them. These innovative tools can transform complex scientific concepts into tangible experiences, fostering a deeper connection between individuals and the ocean. Looking ahead, the future of oceanic vortex research is ripe with possibilities. The questions we ask today will shape the trajectory of discoveries that lie ahead. As we embrace interdisciplinary collaboration, leverage technology, and enhance public engagement, we embark on a path illuminated by curiosity and compassion. The ocean will continue to share its secrets, inviting us to explore its depths and comprehend the vital role of vortexes in sustaining life. What wonders await us as we journey further into this captivating field of study? The swirling waters beckon, urging us to dive deeper into the mysteries that shape our planet. Chapter 10. Conclusion: The importance of oceanic vortexes. Oceanic vortexes, with their mesmerizing spirals and intricate patterns, form the backbone of marine ecosystems. They are more than mere phenomena. They are vital forces that influence weather, climate, and the very life of the oceans. As we reflect on their roles, we begin to understand the profound insights that emerge from the study of these swirling currents. Vortexes not only drive ocean circulation, but also serve as the lifeblood for myriad marine organisms. They create nutrient-rich zones that sustain life and help regulate the climate by transporting heat across vast distances. Imagine the vastness of the ocean, where these swirling currents act like arteries, pumping essential resources and energy throughout the marine environment. The interconnectedness of ocean systems becomes evident when we consider how vortexes interact with various elements of the marine ecosystem. From the tiniest phytoplankton to the largest whales, every organism relies on the delicate balance created by these swirling waters. When vortexes pull nutrients from the depths and bring them to the surface, they catalyze a chain reaction that supports life at every level. Picture a vibrant underwater community, flourishing as a result of this dynamic interplay. The health of our oceans relies on the intricate connections fostered by these vortexes, reminding us that all elements of the marine environment are linked in a delicate web of life. This interconnectedness extends beyond the ocean itself. Oceanic vortexes play a significant role in regulating weather patterns and climate systems on land. Changes in ocean temperatures and currents can influence storm patterns, rainfall, and even global temperature distributions. As marine biologist and oceanographer Walter Munk once said, The ocean is the most important part of our planet. This statement resonates deeply as we consider the implications of our actions on these essential systems. As we contemplate the importance of oceanic vortexes, it becomes clear that our responsibility to preserve these vital phenomena is paramount. The threats posed by climate change, pollution, and overfishing loom over marine ecosystems, endangering the delicate balance that vortexes help maintain. The warming of ocean waters disrupts the very conditions that allow vortexes to form and thrive. Imagine the consequences of a world where these swirling currents weaken or disappear altogether. The potential loss of biodiversity and the collapse of marine food webs would have dire repercussions for both ocean life and humanity. This is a call to action. Conservation and research efforts must be prioritized to ensure the health of our oceans and the vortexes that sustain them. We must advocate for sustainable practices that protect marine habitats and reduce pollution. Engaging in responsible fishing, reducing plastic waste, and supporting marine protected areas can make a significant difference. Imagine a future where our oceans flourish, rich in life and biodiversity, all due to our collective efforts to safeguard them. Moreover, the need for ongoing research is critical. Scientists must continue to explore the complexities of oceanic vortexes, understanding their patterns and behaviors in the face of climate change. Emerging technologies, such as remote sensing and advanced modeling, can enhance our ability to study these phenomena. As we harness the power of innovation, we unlock new insights that can inform conservation strategies and policy decisions. Picture a world where data-driven research guides our actions, ensuring that we protect the oceans for generations to come. The vision for sustainable marine ecosystems embodies hope and resilience. Imagine thriving coral reefs, teeming with life, supported by healthy vortexes that bring nutrients to the surface. Picture schools of fish darting through crystal-clear waters, their populations flourishing due to the rich environments created by these swirling currents. This ideal future is within our grasp, but it requires commitment and action from all of us. The ocean, with its vast mysteries and interconnected systems, is a living entity that deserves our utmost respect and protection. As we reflect on the importance of oceanic vortexes, we recognize that their health is intricately tied to our own. The choices we make today will shape the world we leave for future generations. Let us embark on this journey together, embracing our role as stewards of the ocean, ensuring that the swirling dance of life continues to thrive in the depths of the sea. As we ponder the vast significance of oceanic vortexes, we are drawn into an intricate world that transcends mere physical phenomena. Each swirling current is a testament to the delicate balance of nature, a reminder of the intricate web that sustains life beneath the surface. The insights gained from studying these vortexes underscore their critical role in nurturing biodiversity and regulating the climate. Vortexes are not static. They are dynamic entities that evolve over time. The interplay between temperature, salinity, and wind patterns dictates their formation and strength. Imagine the ocean as a living canvas, where the colors and textures shift with each gust of wind and change in temperature. In this ever-changing environment, vortexes serve as both indicators and influencers of ecological health. They facilitate the mixing of water layers, bringing nutrients to the surface and allowing diverse marine life to thrive. The presence of these swirling currents often coincides with areas of high productivity, where fish congregate and marine mammals feast. This understanding of vortexes as dynamic and essential components of the marine ecosystem invites us to reflect on the interconnectedness of all ocean systems. The ocean is not an isolated entity. It is inextricably linked to the atmosphere, land, and even the polar regions. The swirling currents of oceanic vortexes influence weather patterns far beyond the waves, affecting rainfall, temperature distributions, and even the frequency of storms. As we marvel at the beauty of these natural phenomena, we must also consider the broader implications of their health for the planet. The delicate balance that oceanic vortexes help maintain is increasingly threatened by human activities. Climate change, driven by greenhouse gas emissions, is warming the oceans and altering the conditions necessary for vortex formation. As we witness this transformation, we may wonder, what will happen to the ecosystems that rely on these currents? The potential consequences are staggering. Loss of vortex strength could lead to diminished nutrient transport, ultimately resulting in a decline in marine biodiversity. Picture a world where the vibrant colors of coral reefs fade, where fish stocks dwindle, and where coastal communities suffer the economic repercussions of a failing marine ecosystem. As stewards of the planet, we have an urgent responsibility to take action. Conservation efforts must be prioritized, with a focus on protecting marine ecosystems and the vortexes that sustain them. This includes advocating for policies that mitigate climate change, reducing carbon emissions, and promoting sustainable fishing practices. Imagine a future where marine protected areas flourish, where vibrant ecosystems are safeguarded, and where communities thrive alongside healthy oceans. Moreover, the pursuit of research must continue unabated. Understanding the intricacies of oceanic vortexes requires ongoing investment in scientific inquiry. Encouraging collaboration among researchers, policymakers, and conservationists can foster innovative solutions to the challenges facing our oceans. Consider the potential of citizen science initiatives, where individuals contribute to data collection and monitoring efforts. This collective engagement can empower communities to take ownership of their local marine environments, creating a sense of responsibility and connection to the ocean. The vision for sustainable marine ecosystems is one of hope and resilience. Envision coral reefs bustling with life, their colors vivid under the sun, supported by vortexes that usher in nutrients and energy. Schools of fish dart among the corals, their populations flourishing in a balanced ecosystem. Imagine the sounds of laughter and joy from coastal communities that thrive on the bounty of a healthy ocean. This vision is not merely a dream, it is achievable through our collective efforts. In our quest to understand and protect oceanic vortexes, we must never lose sight of the profound connection we share with the ocean. The choices we make today ripple through time, shaping the future of our planet. As we reflect on the importance of these swirling currents, let us remember that they are not just phenomena to be studied. They are intrinsic to our well-being and survival. As we conclude this exploration of oceanic vortexes, we are left with a sense of wonder and responsibility. The swirling currents of the ocean are a reminder of the intricate and beautiful systems that sustain life. Let us embrace our role as guardians of the sea, ensuring that these vital forces continue to thrive and support the rich tapestry of life that exists beneath the waves. Together, we can forge a path toward a sustainable future, where the ocean remains a vibrant source of life for generations to come. The swirling currents of oceanic vortexes hold a treasure trove of insights that extend far beyond their immediate physical presence. They serve not only as a fascinating subject of study, but as vital indicators of the health of our oceans. For instance, as scientists explore the intricate patterns of these vortexes, they can glean information about broader environmental changes, such as shifts in biodiversity and the impacts of pollution. Imagine each vortex as a living diary, recording the stories of countless creatures that call the ocean home and the changes that affect their existence. In the grand symphony of the ocean, vortexes are the conductors, guiding the flow of nutrients and energy that sustain life. Their ability to mix layers of water is crucial for maintaining the delicate balance that supports vibrant ecosystems. When we observe a vortex, we see more than just a swirl. We witness the interaction of countless elements working in harmony. This interconnectedness urges us to consider our own actions and their ripple effects on the marine realm. How often do we reflect on how the choices we make, from the products we consume to the waste we generate, can impact these distant swirling currents? The ocean's health is intricately linked to our survival, and the threats posed by climate change and human intervention cannot be overstated. The consequences of our actions are manifesting in the form of more intense storms, rising sea levels, and shifting marine species. Each of these changes can alter the formation and strength of oceanic vortexes, leading to a cascade of effects that ultimately impact food security and coastal communities around the globe. Picture a future where the rich bounty of the sea diminishes, where fishing communities struggle to find enough to sustain their livelihoods, all because the vortexes that once nurtured their waters have lost their strength. As we look toward the horizon, the call for conservation and sustainable practices becomes even more urgent. The vision of thriving marine ecosystems depends on our collective commitment to protecting these swirling wonders. We can advocate for policies that prioritize sustainable fishing and habitat protection, ensuring that marine life has the space it needs to flourish. Imagine vibrant marine protected areas flourishing with life, where the dance of nutrient-rich waters continues unabated, nurturing both ocean creatures and the communities that rely on them. Research plays a pivotal role in this endeavor, offering us the tools to better understand the changing dynamics of oceanic vortexes. By harnessing cutting-edge technologies, scientists can track the health of these currents from space, monitoring their movements and interactions with changing environmental conditions. The synergy between technology and oceanography opens new avenues of exploration, allowing us to gather data that can inform conservation strategies. Picture a world where researchers collaborate across disciplines, pooling their knowledge to craft innovative solutions to the challenges facing our oceans. The future of oceanic vortex research is bright, filled with the promise of discovery and understanding. As we embrace the complexities of these swirling currents, we can anticipate a deeper appreciation for their role in sustaining life on Earth. Each breakthrough in our understanding brings us closer to safeguarding the delicate balance of marine ecosystems. Imagine a time when our oceans are not just surviving but thriving, where the beauty and diversity of marine life inspire awe and reverence. In this shared journey, we are reminded of the profound connection between humanity and the ocean. Our choices and actions shape the fate of these swirling currents and the life they support. Let us be mindful of our impact, striving to protect the oceanic vortexes that are so intricately woven into the fabric of our planet. Each small effort contributes to a larger movement toward sustainability, ensuring that future generations can gaze upon the wonders of the ocean and feel its embrace as we do today. As we contemplate the importance of oceanic vortexes, we are left with a sense of hope and responsibility. The ocean invites us to be its guardians, to learn from its rhythms, and to respect its power. The swirling currents are not only vital to marine life, but are also a reflection of our interconnected existence. The choices we make in our daily lives can influence the health of these magnificent waters, and by fostering a sense of stewardship, we can help ensure a vibrant future for our oceans. Together, let us embrace this challenge, forging a path that honors the beauty and complexity of the oceanic vortexes and the life they sustain.